A confirmation about the audio, please. If the audio is clear and available, kindly confirm the same. Thank you. So, hello, a very warm good evening to all of you, and welcome to Baiju's Exam Prep IAS. Now, today we shall be moving ahead with the portion of origin of continents. Now, what is it that we covered yesterday? So, yesterday we covered the portions regarding the aspect of the formation of the planet Earth in itself. We looked at it that how planet Earth came into existence. We looked at the accretion model of the creation of planet Earth, where, to give you a very brief recap, we actually looked at the fact that how across the sun and around the solar system you had trillions and infinitesimal amount of dust particles which were revolving around the sun. Now, as and when they went ahead with collisions, not only did the temperature increase, but also the mass of these particles increased. And that is how they ended up creating the initial building blocks of the planets, what we refer to as planetesimals. And these planetesimals eventually led to the formation of initially the molten ball of mass, that is a liquid ball of mass that was the earlier form of planet Earth. We also looked at the giant impact hypothesis when it comes to the formation of moon. Then after that, we understood the various different layers of the planet, where we looked at the structure in detail, and we understood that the layer or the region that we are mostly concerned with, that is the crust, it is actually the thinnest portion across the entirety of the planet. It extends very significantly up till around 50 kilometers in depth. And that variation is dependent whether we are talking about the continental crust or whether we are talking about the oceanic crust. We have seen that oceanic crust is significantly thinner. Oceanic crust has got a thickness of close to around 5 to 10 or sometimes even 20 kilometers. But then, despite being thinner, oceanic crust is always going to be significantly heavier. And why is that? That is primarily because of that high density of the oceanic crust. And why is it that the oceanic crust has got a higher density? Because of the basaltic rocks, the type of rocks which are constituted there. So we looked at the types of rocks, and that is the basaltic rocks, generally rich in iron, magnesium, and they are dominant in the case of the oceanic crust. Whereas the continental crust, dominated by silica, dominated by alumina, they are the lighter ones, even though they have a significant bit of thickness, but still, always continental crust is going to be lighter one. Then after that, we looked at asthenosphere, which is semi-solid or plasticky layer. And there we have a very high temperature, which is attained primarily because of the presence of radioactive materials present in that region. And which radioactive materials? You have materials such as uranium and potassium. And these materials, under the presence of high amount of temperature and pressure, they undergo a kind of a thermonuclear reaction which produces enough heat to partially melt the materials in the region of asthenosphere. We looked at the various different discontinuities and the types of rocks, the basic properties and features of rocks, along with the aspect when we talk about that what do we understand by the rock cycle, that how one kind of rock can easily get converted into another type, provided there are adequate conditions and suitable conditions which are prevalent. Now, today, what is it that we are going to cover? So, today, we are going to initiate the discussion from the portion of certain theories. So, in this particular module, we are going to talk about certain theories which are relevant for your exams, both for your prelims as well as for your mains exam, but more importantly for your mains preparation. Because here, repeatedly, UPSC does ask you question from this area, be it in the general studies portion or be it even in the optional area. And that is, we are going to study about the continental drift theory, theory of continental drift. After that, we are going to look into the convection current theory. Then after that, we are going to look into the sea floor spreading theory. And you have to understand that each of these theories, even though they have been discarded, but each of them have contributed significantly in order to help us understand how is it that the continents, how is it that the oceans, they have come into existence, why is it that the continents have a certain kind of a shape, where is it that the crust is getting created, where is it that the crustal portion is getting destroyed. All these theories have done their own significant bit in order to contribute to the same. And all these theories eventually end up contributing to the plate tectonic theory. And that is the theory that we are going to concentrate upon. So, out of all of these, UPSC has basically repeated questions in the mains from the theory of continental drift, from the seafloor spreading theory, as well as from the plate tectonic theory. But if you have to finally triangulate upon the important areas very much relevant for your examination, here, continental drift theory as well as the plate tectonic theory, they are going to be the most prominent ones. Now, again, I would reiterate here that the theory of continental drift, the theory of convection current, the theory of seafloor spreading, they are not the valid theories as of today. These have been postulated more than or almost a century back. It is the plate tectonic theory which is followed in order to understand the origin of the continents and the shape of the continents and the oceans and the various different events and landforms that they end up creating in the process. So, all the other theories, all these three theories that we are going to study, that is basically going to be a precursor or a kind of an introduction for us, which will lead us into the portion of plate tectonics. Okay, so this is relevant both for your prelims. In the case of prelims, questions are generally asked from the plate tectonic itself, and otherwise in the mains also, this is going to be relevant. So we start with, first of all, the continental drift theory or the theory of continental drift. Now, can we make notes or relay on Baiju's annotated PPTs? It is up to you. You can make notes as well. You can rely on the annotations of the PPT as well. It is your choice. Gravitational anomaly is basically when we have the condition that around the region of the poles, the planet is slightly flattened. Around the region of the equator, it is slightly bulged. So the gravitational pull of attraction is variable in those cases. Okay. Now, coming to the portion of the continental drift theory. Now, before initiating the discussion on continental drift, here, first of all, let us understand the background. Under what conditions was the continental drift theory, first of all, postulated? And what is it that it wanted to convey? So, you have to understand that ever since mankind became curious about their own understanding, about their place on the planet Earth, they started exploring different areas of the planet. And obviously, cartography was one of those prized professions where drawing the accurate map of the world, that in itself was a very rare phenomena because nobody had explored the world quite significantly. So in the 1800s, at that point of time, you had various different geographers, various different scientists who had basically tried to postulate that why is it so that the continents are arranged in a certain manner. There must have been certain factors involved, that why is it so that we find a condition whereby the shape of the continents appear to be like this. Why is it so that certain areas or certain particular continents, they end up exhibiting a kind of a conical shape here. Now, while this was being researched upon, you had various different geographers and various different very famed geographers at that point of time in the 1800s, including Lothian Green and so on, who basically postulated a different theory altogether. They talked about the contractionist theory. For general studies, you don't need to be aware of, or you are not needed to be aware of what is that contractionist theory. But in one sentence, if I tell you what that theory was, this was about that how upon cooling the earth is contracting, and it is not a perfect sphere, and as it is contracting, it is creating wrinkles on the surface, thereby creating the mountains and the valleys that we come across. Now, initially, because people did not know better, so people would accept that contractionist theory as well. But very soon, people came to an understanding that that theory was absolutely false. It did not make any sense. So you had a school of geographers who basically adhered or attested to that contractionist theory and those older theories. 1900s, and in fact the 20th century, is referred to as the century of discovery. It is in the 1900s and the 20th century where various different types of discoveries, explorations, etc., they came upon materialization. And there we got to know much greater detail about our planet Earth itself. In fact, if I tell you that the details about the interior of the planet and so on, that also became much more clearer in the 1900s. So, initially, in the first decade of 1900s, that is somewhere around 1907, you had for the first time a geographer with the name of F.B. Taylor. F.B. Taylor. Now, F.B. Taylor in 1907, he talked about the fact that look, while all of us are pondering about, or all of us are thinking about that how these continents, they have attained certain kind of a shape, or why they are in the location that we find them in, so it might be possible that the continents are actually moving with respect to each other. So it was for the first time where this idea was actually sown into the minds of the people. And F.B. Taylor is a pioneer in that regard, is considered to be a pioneer in that regard, because he explored the possibility that the continents can move. But then he did not develop this theory, because when you provide a kind of a theory, you need to be able to provide a certain amount of reasoning for the same as well. You need to make certain assumptions as well. You need to be able to prove that theory. That if you are saying that the continents are moving, why should I believe that the continents are moving? Show us the proof. Do you have any proof for the same? F.B. Taylor did not have any kind of that study. So F.B. Taylor was pretty much someone who simply postulated an idea and then disappeared. Even though his contributions in geography are numerous, one of the contributions being that aspect that the continents could move, but then in this case, he did not contribute any further. Now, as the famous anecdotal story goes, you had a German meteorologist, or rather a German climatologist, with the name of Alfred Wagner. Okay, you had a German climatologist with the name of Alfred Wagner. Now, he was a climatologist by profession, and his specialty was to study climate change. And Alfred Wagner would oftentimes go into the region of Greenland, and study the various different ice deposits to understand that how climate has been changing in the past history of the planet. Because when you take a look at the records of the ice deposits and you dig deep into the ice, that is why even today you will find many people and many of the climatologists, they actually work in the region of Antarctica, in the region of Arctic, in Greenland, where they explore these ice deposits. They dig deeper to find out that if the ice had been deposited in that place, let's say 100 years back, and the nature of the ice particles gives you an idea about the type of gases which would have been present, the type of temperature which would have been present at that point of time. So that was a specialty of Alfred Wagner. Now, as the famous story goes, on one fine Christmas Eve, Alfred Wagner was presented with a very special gift from his friend. And that gift was nothing but the world map. World map, something that we stick onto our walls nowadays, and we don't even care what kind of map it is and where various different countries are. We don't even care, we simply stick it on the wall. But you have to understand, around 100 years back, that was a very rare commodity, because an accurate depiction of the world map in itself was a very rare phenomena. Alfred Wagner was presented with one such physical map of the world. Now, once Alfred Wagner looked at the physical map, few of the things struck his imagination immediately. And what were those things? So, first of all, he observed the shape of the continents and oceans. And thereby, he observed certain facts. He looked at the fact that if you take a look at the shape of the Arabian Peninsula, and if you take a look at the shape of the Horn of Africa, the shape resembles quite significantly. And also, the shape, if you take a look at the eastern part of South America, and when you take a look at the western part of Africa, the shape is strikingly similar. Similarly, the shape of western coast of India and the shape of the eastern coast of Madagascar, they were also very similar. Now, upon looking at all these coincidences or all these aspects, Wagner was absolutely convinced that this cannot be a sheer coincidence. How can it be a coincidence that land masses separated by thousands of kilometers of sea, how is it that they have a resembling shape? It is simply impossible, isn't it? Now, by the 1900s, at that point of time, automatically and already, significant serious researches had been carried out in order to understand the various different plants, rocks, animals, fossils, etc., which were to be found across all the continents. So you had the paleontologists who had basically studied about the various different types of fossils present in various different areas. You had the geologists who had studied the rock formations, and they had all documented those various studies, but nobody had collated them. Alfred Wagner, being curious that he was, once he observed and once he noticed the kind of these similarities exhibited by the various different land masses, he started studying those various researches which had been carried out by the people before him. And upon studying all of this, then he postulated around 1912 what is referred to as the continental drift theory. So Alfred Wagner is basically credited with continental drift theory. Now, what was this theory all about? Continental drift. What do we understand by drift? Any kind of movement which is initiated, right? That is what is referred to as drift. So, what he said was that look, if we infer and interpolate the various different evidences exhibited by the various different scientists and so on, so that tells us that some time back, or rather a long time back, rather than having all these various different continents, we had a supercontinent, a large supercontinent, which he named as Pangea. And all the land masses were included within that. Then, after that, you had water body surrounding that Pangea. And that water body, he named it as Panthalassa, or ocean of the world. Now, you have to understand that initially, when Wagner published his theory, that theory was published in German. He was a German meteorologist and German climatologist. So he published his entire essay in the form of a small book in German. Now, that was not immediately available for the entire world to come across. The rest of the world came across that theory only around 12 to 13 years later in the 1920s, when the English translation was made available. So, majority of the terminologies that you come across, that has a kind of a German connotation. That is why Panthalassa was referred to as the ocean of the world. In fact, Wagner went ahead to say that look, even the Pacific Ocean that you come across, even that Pacific Ocean is the remnant of that ancient Panthalassa. And basically, he said that this Pangea, it broke into various parts. That Pangea broke into two different parts initially. It broke into two different parts. You had the one to the north and one to the south. The one to the north was named as Laurasia. And Laurasia, in the present day scenario, if you have to identify, would consist of the land of Europe, Asia, other than India, okay, this portion of Asia, and also North America and Greenland. Whereas the southern component, that would be referred to as Gondwana land. Gondwana land. And this would include the continents such as South America, Africa, India, Madagascar, Australia, and Antarctica. All of them were constituted in one. And then he postulated that look, these continents further, or these supercontinents further broke into various different parts, and the continents have been drifting ever since that point of time. And that is why we have the present day shape of the world that we come across. Now, how is it that Wagner could postulate such a kind of a theory? So basically, Wagner postulated this theory based on the evidences that he saw. Evidences based upon the researches and the studies carried out by the geologists, evidences indicated by the various researches carried out by the paleontologists, those who study the fossils, and so on. But then, when you provide a theory, you need to be able to provide the reasoning as well. That if you are saying that the continents are drifting, why are they drifting? Now, while all the evidences that Wagner accumulated, all these evidences pointed to the same fact that yes, the continents might be drifting from their original position, the continents might be moving. But when it comes to providing the reason for the same, being a climatologist by profession, Wagner did not have a specialty in that area. So the reasons that he cited were so very flawed, so very incorrect, that continental drift theory was completely rejected at that point of time. In fact, continental drift theory was not only rejected, but Wagner was ridiculed across the entirety of the geographical community. All the various different geographers, they basically were divided into two different schools. One were referred to as those who believed in drift of the continents, and other ones who would believe that the drift is simply not possible. Because you have to understand here, you have to imagine that right now it is easy to imagine that yes, the continents might be drifting, but 100 years back that was close to around blasphemy. That how can you say that the continents are drifting, the land that we have been living in, the thick land and the heavy land that we have been living in, which spans for hundreds and thousands of kilometers, some random individual is telling us that that land is shifting and is drifting? Nobody would believe him. Obviously, further to add on to the fact that Wagner was German. And after First World War, obviously the impression of Germany was not positive. So the entirety of the Western world, the scientific community, they boycotted Alfred Wagner's works and they humiliated him. So much so that e- even though the translation of that or the English translation of the theory was something which was provided in the 1920s, almost a decade later than when Wagner initially postulated this theory, Wagner basically quit all this and he continued his study of climate change. In fact, it was during one of his journeys towards Greenland, where he was going to study the climate change that planet Earth has been witnessing. It was during one of these journeys that Wagner eventually died. And till his death, continental drift theory was not only ridiculed, it was something which was talked in great degeneration. But then, only later on, many decades later, one realized, based upon the other evidences, that indeed continental drift theory is something, or the entirety of the aspect or the possibility that the continents can drift from their original position, that can be a reality. Even though the reasons cited by Wagner, they are still incorrect because that was not his specialty. So, in this theory, when we study this theory, what do we study here? First of all, in this theory, we study the evidences provided or indicated by Wagner, then assumptions made to prove the theory, and also the reasons for the drift. So these are the three factors that we are going to study in detail. What were the evidences indicated, what were the assumptions made, and what were the reasons indicated for the drift. Out of all of these two, that is the assumptions and the reasons, they were absolutely incorrect, due to which his theory was ridiculed, his theory was rejected. But first of all, let us think about the reasons which Wagner saw, the evidences which Wagner saw, which convinced him that the continents that we see, that we live across, they are not a stable mass. They themselves are prone to change and they themselves are moving from one place to another. So, first of all, we shall be taking a look at the evidences. Okay? Evidences provided. Yes, Laurasia is also referred to as Angara land. Now, amongst the evidences which were provided by Wagner, let us understand why Wagner thought about it. Being a climate expert, why did he think, or why did it dawn upon him that indeed the continents would be changing their place? So, the first inkling or the first idea that he had was that of the shape of the continents. Basically, when he took a look at the shape of the continents, they appeared to match with each other. And that was too significant a fact to be referred to as a coincidence, where the continents would simply fit upon each other. It appeared as if there was a kind of, I'm sure all of you would have witnessed or played with jigsaw puzzle in your childhood days, where you had various different puzzle pieces, you arrange them, and then you get a larger picture, isn't it? So he basically, when he took a look at the continents appeared to make a kind of a jigsaw fit, where if you remove the water body in many of these areas, they would have the same shape. Now, how is it possible? So, this was the first inkling that he had, the first evidence that he provided. Then, after that, what were the other evidences? So, the second evidence was a geological evidence. And what was that geological evidence? So, basically, for that, let us take a look at the world map. Now, amongst the geological evidences that he provided, that one of those most evident ones was basically the geological rock structure. Now, rocks are formed in their own process. We have taken a look at how the rocks are formed initially by the cooling down of molten materials. So, when a rock is created, when a rock is formed, at that point of time, it has got a unique property, right? So basically, he observed that when he looked at the rocks in the region of the Appalachian Mountains in the eastern portion of North America, and then he looked at the rocks in the Scottish Highlands. Now, these rocks, they resembled not only in their age, the precise age, but they also resembled in terms of their formation, in terms of their geological structure. Again, that was too eerie a fact to be regarded as coincidence. And that could not be possible that rocks in altogether different areas, they have the same kind of formation. Furthermore, he also observed that the rocks that you observe in the region of the Brazilian highlands, they have a striking similarity to the region of the western portion of Africa. So that basically indicated to him that, look, it might be possible that all these places would have been together at one point of time. And North America actually has drifted westward from the region of Europe to come to in its present position. And also, South America has also drifted westward, and thereby it is present in the current position. So, this was about the geological structure. But something else struck him. So when we talk about the similarity of the geological structure, so presence of similar mountain ranges across the region of North America and Europe. For example, the Appalachians of North America are similar to the Scottish Highlands. They have been created at the same time. They have the same structure. They have the same mineralogy. They have the same component as well. So it cannot be possible that simultaneously similar and exactly same rocks are created thousands of kilometers away. Similarly, geological rocks in Western Africa and South America, they also indicated a kind of a similarity. Now, after this, you had another aspect, and that was the aspect of placer deposits. Now, what do we understand, or what is the meaning of placer deposits? First of all, let us understand that. Placer means something which is placed, isn't it? So let's suppose when you have a condition whereby, let's suppose you have a mountainous area in this region. Okay. Let's assume in this mountainous area, you have a kind of a mineral abundance. Let's suppose any particular mineral, let's assume gold. Gold which is not soluble in water, or any kind of mineral which is not soluble in water. Now, if a river flows through this particular region, let's assume a river is flowing through the slope. Now, as the river is flowing through, that particular river will carry significant amount of these particles, isn't it? Significant amount of these particles will be carried by the river as the river flows. As long as the river has got certain amount of speed, that river will be able to carry those particles. But eventually, when the river loses that speed, these particles that the river has carried all along, these gold particles which the river has carried all along, they will be deposited somewhere here. Okay. So these deposits, which have been created a large distance away from their sources, they are referred to as placers or placer deposits. These are referred to as the placer deposits. Okay, they have been deposited some distance away. Now, in this case, in this situation, how is it that it pointed to the continental drift? Basically, he found out, or he observed, that you had significant amount of gold deposits which were found in the region of western part of Africa, and those gold deposits did not have any source rock nearby. For any placer deposit, you need to have a source rock. Source rock. Okay, for any kind of placer deposit, you need to have a kind of a source rock. So he basically observed that in the region of Western Africa, there are huge placer deposits of gold. Okay, but the source rock is not to be found in the region of Western Africa. Upon greater deliberation and greater investigation, he found out that the gold or the source rock indicating those placer deposits, they are to be found where? In eastern part of South America. So the placers which were present, the gold deposits which were present in the Western Africa, you had the source rock present in the region of eastern part of South America. How is it possible? How is it possible that from here the deposits will be carried out across the Atlantic Ocean? Simply unfathomable, impossible. That can be possible only in one case: if South America and Africa were at one point of time together, and South America, since that point of time, has drifted westward, just like North America. So that was his understanding, and that was another evidence. So here, he basically observed the placer deposits of gold to be found in Africa had their source rock to be present in the Brazilian highlands. This could be possible only if the two would have been together and South America drifted to the west. Okay, so that was another idea. Again, very quickly, what is placer deposit? So, any kind of deposit which is carried out very far away from the source rock or the source material. For example, you have gold deposits, you have platinum, you have uh, even in certain cases, you have silver. Now, any of these elements which are not soluble in water. So, when water or any of these agents, they carry them through and deposit them some far away distance, that is what is referred to as placer deposits. And the place from where those deposits have originated, that is referred to as the source rock. So, for the placer deposits of gold to be found in West Africa, the source rock was found to be present in South America. It could have only been possible if both of these continents would have been together and South America eventually would have drifted significantly westward. Now, furthermore, he had other kind of evidences as well. One of the other evidences was that of tillite deposit, or rather the glacial evidence. Now, in the first class itself, we have seen what glaciers are. Glaciers are the massive blocks of ice which end up moving down the slope at a very slow rate. at a very slow speed, they end up moving down the slope. We have looked at that, isn't it? So, when we talk about the various glacial evidences which were present, so wherever at any point of time a glacier has ever been in existence, that glacier would leave behind evidences in a way which no other agent of nature can create, because the glaciers, they exert such a huge amount of mass, they surface of rocks as they end up moving, what is also referred to as glacial striations. I hope we are able to understand the meaning of striations in general, right? What is the meaning of striations? Linear or sinuous lines that you have. Okay, so you have these striations. So wherever the glaciers would have moved, they would have indicated these striations, the formation of these lines, because the weight exerted by the glaciers, that weight cannot be exerted by any rock, that weight cannot be exerted by any moving river, any wind action, any sea wave action. So that is very unique. Now when a glacier moves, simultaneously it will, let's suppose this is the rock surface and the glacier is moving on top of that, not only will it be able to scratch the surface, it will carry small particles, and those particles will also get deposited. Now those fine particles deposited by glaciers, they are referred to as till or glacial tillite. So when we talk about glacial till or tillite, right, so here till or tillite, they indicate are the very fine particles carried by the glaciers and eventually deposited. Okay, so this glacial till or tillite can be in existence only where the glacier has ever been in existence. They can never be in situated in a place where the glacier has never been in existence. So, the glacial evidence which Wagner looked at, that included both the portions of glacial striations and the tillite deposits. Now, both of these would indicate that at some point of time in the geological history of that place, a glacier would have existed in that region. Now here, let me first of all show you what a glacial striation looks like. Striation basically refers to a kind of a sinuous line, a linear line-like structure. So observe this particular image here. Now here, I want you to observe the lines created on the rocks. These linear lines which have been created on these rocky surfaces. Now all of this carvings on the rocks, they can never be created by a river action. A river also erodes the rock, but not like this. A wind can never erode a rock like this. It can be carried out only by a glacier. So this indicates the presence of glacier in that region at some point of time in history. Now, where did he find the evidences of glaciers? So he basically found the evidences of glaciers in those parts of the world where right now no icy regions or no glaciers exist at all. For example, he found the evidences of glaciers, and geologists have found the evidences of glaciers significantly in the peninsular part of India. Significant amount of peninsular part of India, they exhibit the presence of or evidences of glacial presence in history. For example, when we consider the Aravalis in Rajasthan, they also indicate that at one point of time in history, they had glaciers. Similarly, in the peninsular part of the country as well, various different places indicate that. Then, in the southern part of Africa, in the southern part of South America, in the southern part of Australia. In all these places, he found evidences of glaciers. Now, it did not make much sense to him that how is it possible that at one point of time in history of this planet these places were covered with glaciers, and today these are very warm and hot places and no evidence of glacier at all. So there could be only two possible logical explanation for them. One logical explanation would be that the climate of the planet has changed so significantly that at one point of time these areas were covered under glaciers and now they have completely melted out. The other explanation could be that if you fit all these places together, it might have been possible that these places indicate the early Gondwana land. These places would have been together and they have actually drifted apart. And that is what he did. So basically, he looked at it and he observed this. This is where the glacial striations and also the tillite deposits have been observed significantly. Now, just taking a look at this map, it does not make much of a sense. But if you try to place them all together, and if you try to create that ancient Gondwana land, then it makes perfect sense that it might be possible that all these land masses at one point of time in the history, they would have been situated very much close to the South Pole, along with Antarctica, and these would have been frozen. And that is why evidence of glaciers. So this also indicated that the continents would have been together in the past and they have drifted since that point of time, and they have drifted into their present and current positions. Right? So this was the glacial evidence. Now, then after that, here he also came across the another set of evidence, and that was based upon the study carried out by the paleontologists, the paleontologists who basically study the ancient remnants of fossils. So the paleontologists, when they carried out their study, they had observed the evidence of certain fossil remains of certain types of species spread across various continents. For example, you had one of those freshwater reptilian species with the name of Mesosaurus. Now, Mesosaurus was around 8 to 10 feet long reptilian species which would exist only in freshwater. But then fossil remains of Mesosaurus have been found in South America as well as in southern part of Africa. Now, how is it possible? How is it possible that the same animal could be found in so very different places, separated by thousands and tens of thousands of kilometers? It, it is a kind of a freshwater reptile, so you cannot even argue that this reptile would have, on one fine day when that reptile would have felt adventurous, that reptile would have started swimming across the Atlantic Ocean. Eventually, few of them would have reached Africa and they would have populated Africa. That cannot be the case because it is a freshwater reptile and oceans are salty, they are saline, they cannot survive there. So, how is it possible? Similarly, you had the evidences of Cynognathus and its fossils spread across again both South America as well as Africa. Then you have the evidence of Lystrosaurus. You have the Glossopteris, which is a kind of a fern, again indicating the presence across multiple continents. Now, this could only have been possible if the land masses could have been together. Otherwise, you cannot have the same kind of species simultaneously coming into existence in different places altogether. That goes against the entire theory of evolution of species provided by Darwin, right? That simultaneously you have a new species of, let's say, human beings created there also and in other place also. That can never be possible. So, that again indicated the fact that these species would have been, or these entire landmass would have been together. And this landmass has since that point of time drifted. In the case of North and South America, they have drifted westward. In the case of Africa, India, Australia, they have moved away from the poles. They have moved towards the equator as compared to the earlier scenario. So, based upon these sets of evidences, Wagner was absolutely convinced that all the continental land masses would have been together and they have drifted. And that formed the theory of continental drift. So this is a kind of a concise representation of that theory. So here, when we talk about it, so what is it that he proposed? First of all, there was a huge landmass known as Pangaea. It was surrounded by a water body known as the ocean of the world, or Panthalassa. And this is the artistic recreation of what the Pangaea would have been, even though this is something purely left to imagination. So all the land masses would have been one. And then they drifted away. So how did they drift, or in which direction did they move? So as per Wagner, based upon the evidences, and we have also talked about it repeatedly now while discussing, the drift has been made possible in two distinct directions. One of the direction is westward, whereby he was convinced that North and South America, they are drifting westward away from the region of Africa and Europe. So he was convinced there is a westward drift. Okay, westward drift of continents. Example, North and South America. And then he was also convinced that you have various continents such as South America, Africa, as well as India, Australia. They have moved away from the poles towards the equator. So, movement away from the poles towards equator. So, as per Wagner, these were the drifts which were happening. Now, till this point of time, his theory will make absolute sense. And Wagner would appear to be the most intelligent person that you have come across. And if you read only the evidences, you will always be thinking in the lines that why is it so that no other geographer before him could think about it? If it is so apparent that these evidences, all of them, they indicate that the continents are drifting, why nobody accepted it? And why nobody before him could think about it? That was because of the reasons that he cited, reasons indicating why this drift is happening. And that was so very ridiculous. That was so very incorrect. That is why the entire theory was rejected. But then, before directly jumping into the reasons cited by Wagner, in order to provide the reasons, he made certain assumptions. And we will take a look at the assumptions cited by Wagner. So, Pangaea broke up to form different continents, and continents drifted away to form the present shape. Now, what were the assumptions, first of all? Assumptions made by Wagner to prove his theory. What were the assumptions? Now, Wagner was a climatologist. That is something I have repeated multiple times. Why I have repeated that multiple times is to help you understand that he had no clue about the interior of the planet. And at that point of time, even the greater scientists, they were still finding out about the interior of the planet. We are talking about the early 1900s. 1912 is when he published this theory. Now here, he basically borrowed the idea. So if, let's suppose, I'm an individual who has got no clue about physics and I have to provide a reason for physics, what do? I go to the best known physicist that I know, I take upon his idea, and then I provide it, right, in order to ascertain what I'm trying to prove. So Wagner did the same. So he borrowed the idea about the interior of the planet from a great Austrian geologist, that is Edward Suess. Edward Suess is a name that you will come across even when we talk about the formation of northern plains in India, because he provided the most apt theory. Now, Edward Seuss had provided a theory about the interior layering of the planet Earth. So, the first assumption that he made was about the layering of planet Earth. This was borrowed from Edward Seuss. He was an Austrian geologist. So, German climatologist, a neighboring region, Austrian geologist, he trusted him and he borrowed his idea. Now, what is the theory or what is the idea about the interior that Edward Seuss had said? Edward Seuss had basically said that look, the entirety of the planet is basically divided into three very distinct and uniform layers. Or rather, he basically had said that the planet is simply divided into three layers. The topmost layer, which he referred to as the or which we refer to as the crust, he said that this is made up of silica and aluminium, and that is why it will be referred to as Sial. Okay. Then he said that the region of the mantle that is made up of silica and magnesium, and that is referred to as Sima. And then he said that the region of the core is dominated by nickel and iron, and that will be referred to as Nephi. Okay, all these represent the mineral composition. So he simply borrowed that idea that all of these are in uniform composition present. The crust is only Sial, mantle is where we have Sima, and then we have the core, which is Nephi. But then, even if he would have assumed only till this point of time, even that would have made sense. But he went a step further. He went a step ahead. He said that the continents, they represent Sial, all the continents, whereas the oceanic crust, that represents Sima. And he further went on to say that all these continents are freely floating over the region of Sima, just like how a boat floats on water. Okay, I will write it down for a better understanding as well. So he said continents would represent Sial, they would float freely over Sima. This was the assumption that Wagner made. Now, they would float freely over Sima, just like just like a boat on water. Now, does this make any sense at all? Can the continents, the large continents that we live in, can they be floating freely like boats on water? Think about it. Apply your own logic. Does it make any sense? Absolutely no. Correct. It doesn't make any sense. But this is what Wagner had thought about. And this is what Wagner assumed. And why did he make these assumptions? In order to provide the reasons. Reasons for what? Reasons for the westward drift of the continents and the movement away from the poles. But then you understand one basic fact. So when you have, so that you are able to understand the reasons as well easily. Otherwise, the reasons don't make any sense at all. But if you understand this assumption, you would know where Wagner is coming from. So if you assume that you have water, significant amount, and you have a boat floating on that water. Let's assume. Now, when a boat floats on water, it is free to move anywhere in any direction. And along with that, boat also experiences an upward force. Are we aware of the fact that anything which swims or anything which floats, that experiences an upward force? What is that force referred to as? Very good. That is referred to as the force of buoyancy. So anything which floats experiences the force of buoyancy. Right? Now, this is what he said, that the continents also experienced the force of buoyancy. Also experienced this force as they floated above Seema. Okay, they also experienced this force as they would float above Seema. Now, based upon these assumptions, he provided the reasons. Now, Wagner had to provide two reasons, or reasons for two kinds of movements. Which kind of movements? One was the westward drift of continents, and the other was the movement away from the poles. So, both the reasons that Wagner provided, they were to indicate that. So, the reasons cited were two, right? To prove two kinds of movements. One, westward drift of continents. And second would be movement away from poles. Okay. Force of buoyancy. Force of buoyancy is the force, the upward force which is applied when you have any object which is floating. So you can try this experiment at your house as well. If you, let's say, have a thin wooden plank, or let's say if you have a thermocol piece, keep it on a bucket of water. You will find out that it is floating. Now try to immerse that piece. Try your level best to sink that piece with your hand. You remove your hand, immediately that comes to the top again. I'm sure you would have observed that. Try it with a mug as well. Anything that you try it will come back up. So, what is that force which pushes the things up to float on that fluid? That is basically force of buoyancy. So, force of buoyancy is that force which keeps things afloat. Okay. So, because Wagner said that the continental land masses, they indicated Sial, and they would be floating freely over the region of Sima. So, that is why they would experience that force of buoyancy. Right. Now, here, let us understand the reasons that he provided. So, for the first, that is the westward drift of continents. For that, he provided the reason in order to prove westward drift. He provided the reason that it was done by the gravitational pull of sun and moon, which he also referred to as the tidal force. Okay. Now, by the way, all this meanwhile, please don't get carried away that how can he say this? How is it that Wagner is saying this, etc., etc.? Because this theory has been rejected more than 100 years back. Okay, so please let us not try to prove his theory correct 100 years later. His theory evidences have been correct, but then the assumptions and the reasons are incorrect. So any aspect that you are taking a look into, you have to understand that this theory has been rejected. Okay, so here when we talk about, let's say, the aspect of the gravitational pull of the sun and the moon, what is it that Wagner meant by that? First of all, when we talk about, let's suppose this being the planet Earth, let's suppose this being the sun, and then let's suppose this being the moon. Now, this is your sun, this is the moon, this is the earth. Or I'll do one thing, I'll remove the labeling here. Now, earth had various different land masses in the form of Laurasia and Gondwana land. Now, planet Earth would consistently rotate around its axis from a direction of west to east. Right? Now, this is where things actually not only do they get interesting, they also borderline on the verge of being funny. So, what did he say? He said that look, as the planet would rotate continuously from west to east, there would be a very strong gravitational pull exerted by the moon as well as the sun. Even though the sun's mass is significantly greater, gravitational pull exerted by the moon would be much higher. Why? Because the distance between moon and earth is less, which is correct. The gravitational pull exerted by moon is also quite significant on the planet. So he said that look, the planet was revolving. The planet is something which is rotating continuously along with the land masses. Meanwhile, the moon is exerting that gravitational pull of attraction. Now, that gravitational pull of attraction is not so strong that it would stop the planet in itself. But then it is strong enough that it would hold the land masses in their original position as the planet would rotate underneath them. What is the meaning of that? So, suppose you have a planet consisting of these land masses. So, the moon would hold these land masses in their place as the planet would continue to rotate. Imagine that scenario. If the gravitational pull extended by moon is so very strong that it would hold the land masses in their own place as the SEMA underneath would continue to rotate. Now, in that scenario, what would have happened? In that scenario, these lands, they would crack up. The land would crack up. Why? Because the land was being held by the moon, apparently, as per Wagner. And as not only would they crack up, eventually this land, after some time, would get separated. This land would get separated here because it is being held by the moon as the planet is revolving. Right? So, that is where he would prove that North and South America are drifting in the westward direction because of the gravitational pull extended. Now, is that reason true? Absolutely not. That reason is incorrect. Why? Does moon exert no gravitational pull? It does. Moon exerts a significant amount of gravitational pull on the planet Earth. It is because of the gravitational pull of the moon that we basically come across the various different tidal movements across seas and oceans. But then, the gravitational pull is nowhere as strong to hold the land masses in their place, and the planet would continue to rotate underneath it. So that is why, if the gravitational pull of the moon would have been that strong, the entire planet Earth would have stopped rotating within 50,000 years itself. But the planet has been rotating for 4.5 billion years and counting. So obviously, this reason was incorrect. So here, this was the reason. And what is it that he cited? That moon gravitational pull held the land masses in their place, as the planet would rotate. As a result of this, the land would be broken, and the broken parts broken portion of the land would move to the west. Why? As the planet is rotating from west to east. Okay. So the planet is consistently, think about it, the planet is consistently rotating from west to east. Here is your moon. The moon is holding the land masses. So if the land mass, let's suppose on the planet finally breaks and is being held by the moon, so as a relative velocity or as a relative position from the planet Earth, what movement or what direction of movement would you observe for that land? Again, I will repeat. Think about it again. The planet is rotating from west to east, right? That is a continuous rotation. Here is your moon, right? So this is rotating from west to east. Here is your landmass, which is being held by the moon. So eventually it will break and moon will be holding it as the planet rotates. So the other part of the unbroken landmass goes with the planet, whereas this one stays where it is. So in the relative motion, which direction of movement would you ascribe that kind of association or that kind of movement exhibited by the land? It will be in the westward direction. So that is how he proved, or that is the reason that he cited to indicate the westward movement. Okay, is that clear? Is that something which is understood, or is there any doubt which prevails? Good. Sakshi, poles always attract things. Then how India moves towards equator? Okay. Again, I told you, please don't get carried away by this theory, because this theory again has been ridiculed, has been rejected. This theory is no longer existent. But I would contradict you even on the basic fact that the poles always attract things. The poles, they have a slightly greater gravitational pull of attraction as compared to the equator, but it is not drastically greater. Okay, so that is again something which you have to clarify in yourself. Why can't continents float on oceans? Because the oceans also have a crust. They also have a continuous landmass which eventually mixes with the continents themselves. Then again, other land would have touched by eastward. Yes, Vishnu, correct. Glacial evidence is not clear. Glacial evidence, basically, Wagner found the evidence of presence of glaciers in those areas where today you don't find any glaciers. For example, southern part of India. Do you have glaciers in southern part of India? Absolutely not. But the evidences of glaciers are present in southern part of India. And so is the case with southern Australia, southern Africa, and southern part of South America. So how is that possible? That can be possible only if all these land masses would have been together and they would have been present around the region of the South Pole. Okay. Now, so I want you guys, the things that you have not understand, please point it out, that what is it that you have not understood. Okay, please point that out. Okay, I simply won't entertain the question that repeat everything again. I won't be entertaining that question. For that, you have the recordings available. Point out which is the portion you have not understood, and we'll solve that query. If this theory is proved wrong, then why are we studying? Because UPSC asks this question multiple times. If that is not enough for reason for you, then this is a theory which eventually helped us understand the plate tectonics theory as well. Okay. Priyanshu, if this theory was rejected, then why this will ask in exam? Okay, because UPSC gains a certain amount of fun by asking these kinds of questions. Just like you gain a certain kind of fun by these questions, similar is the case with UPSC as well. Is Sial not containing oceanic crust? Sial, its entire classification in itself is not very proper, because oceanic crust does consist of silica, alumina, magnesium, iron, etc. So that is why Sial is no longer used as a proper reference for oceanic crust. Can we make this diagram if the question? Absolutely yes. Still continents are moving or not? Absolutely yes. Should this write in mains? It's if it is rejected, why should it take in civil services examination? I don't know. You can write a mail to UPSC DOPT. Why are they asking these questions if this theory has been rejected? Why is it that they are asking questions about it? You can go to the nearest MP or MLA. You can ask them to represent this question in the parliament as well. But then they do ask this question. And it is not only restricted to geography itself, even any optional subject that you will study, any kind of optional subject that you will study, you will read about theories which have been provided 500 years earlier. Now, those theories are not prevalent, those theories are not relevant, but UPSC still asks them. Why? To gauge your level of understanding, that whether you have simply ratified what is given in the book, or do you have a deeper understanding of what is going on. Okay. And sir, if the theory has been rejected, then why even today we use the term Gondwana? So the term Gondwana land has been taken from the central portion of India, where you have the Gond tribes which have been living there. So that is where the term Gondwana land has been derived from. Okay. Second evidence I have, which is the second evidence, Tehseen? Please point out. Fossils evidence, the evidences of fossils to be found across different continents. How is it possible that the same species, the fossils are to be found in different continents? For those of you who are not aware about the theory of, how many of us have never come across the theory of evolution of species by Charles Darwin? How many of us have no clue that what is the theory of evolution of species? Okay. Meanwhile, in the parallel universe, I have a question: how to read the maps along with the geography syllabus. So, my dear friend, my dear knowledgeable colleague and friend, I know you are very knowledgeable. As of now, please have patience. Please let us talk about continental drift theory. If you have understood continental drift theory ably well, have some patience. I'll talk about map pointing later on. Okay? Yes, Ritu, Laurasia and Angara land are the same. Chandrasekhar, in your given PPT notes, there is no much enough detail regarding this theory. Which PPT notes have I provided? I have not provided any kind of PPT notes. Are you copying notes from somewhere else? Then I'm not responsible. Okay. It is prelim specific or main specific. Okay. See, the amount of fun that I have by reading the questions, that is simply unparalleled. So please pardon me if I take some more time about uh, by reading the questions. I have a concern about paleoclimatic evidence. What is the concern that you have? Concern means you are worried about it. What is the worry that you have about paleoclimatic evidences? Okay. Paleoclimatic evidences basically they borderline to the aspect of the glacial evidence. That how is it possible that in these areas you have the presence of glaciers or the evidences of the presence of glaciers, where in today's world you don't find glaciers at all? Basu, I have already replied to your question, and that is Sial not containing oceanic crust of Suez? So basically, you have to understand that this is when we talk about Suez and his postulation. So he talked about Sial, Sima, and Nife. He did not deliberately distinguish between oceanic and continental crust. He just talked about the crustal portion representing Sial. Okay. Now, coming back to it, I understand both of you, all of you have a similar kind of an issue. So most of you. So first of all, understand that any species which comes into an existence or which comes into existence anywhere, that species will not come randomly anywhere, right? Or it will never be the case that a species is created at the same time. Or take the case of the humans as well. Do you think human beings were simultaneously they evolved in multiple different places? That you had human beings in the region of Africa as well, South America as well, North America as well, etc.? No, that is not how it happens. You have the evolution of species. The species evolve. From one shape, they evolve into another shape. And slowly and steadily, they morph, they change. So, when we talk about human beings, they first of all appeared where? In Africa. From Africa, where did they go? They went to Asia. From Asia, where did they go? They went ahead with the land bridge, the land which was connecting North America. That is from the region that you see as Bering Strait now, and the Bering Sea differentiating Alaska and Russia. At one point of time, that was a landmass. So it is through that landmass that human beings eventually entered North America. And then through the North American region, they would enter the region of South America. While they were in Asia, they also went ahead across the Caucasian region into Europe. That is how the entire world was populated. And after they lived in that region for significant amount of years, they developed changes accordingly. And that is how you have different races of human evolution. Those of you who have taken anthropology as your optional, you would be studying. If not already studied, you would have been studying this in significantly greater detail, right? Or you would have read the book Sapiens, another very famous book that people read or people generally have with them. Even if they don't read for fashion statement, they keep it with them. So there also you get an idea about this evolution of species. So all the species, they have evolved, or what is referred to as speciation, that has happened in one place. From there they have distributed across. So now when I take you back to the fossil evidence, or evidences indicated by the paleontologists. So, what the paleontologists actually indicated was that look, you have, for example, a freshwater reptile. Now, how do you get an idea whether it is a freshwater reptile or whether it is a saltwater reptile? By looking at the kinds of evidences of food that it would consume. So, those evidences indicate that, for example, Mesosaurus was a freshwater reptile. And Mesosaurus fossils have been found simultaneously to be present in Africa as well as in South America. Now, how is it possible? There can only be one possibility, that there cannot be a possibility that Mesosaurus would have come into existence and then they would have swum across the salt water to reach Africa. No, there can only be one possibility if both these areas have been combined together. So that is the paleontological evidence. Okay. Now here, when we talk about Sakshi, then why human beings have different colors? Because we have adapted to our own climatic conditions over a period of thousands of years. When you live in a particular region, you are exposed to a certain kind of climatic condition, your body also changes. We all have a tailbone, isn't it? All of us, we have a tailbone. Now, have you ever asked the question, why don't we have a tail? If we have evolved from monkeys, why don't we have a tail? Have you asked that question? That is how the evolution works. So in general, I would suggest to you, recommend to you, that this is something that you should be aware of. That is, the theory of evolution by Charles Darwin is something that you should be aware of. Okay. Yes, Sayed, that is correct. Now here, when we talk about, let's say, the reason cited by Wagner, now this reason basically talked about, and he wanted to prove, the westward drift of the continents. Now, for that, what he said was, look, the continents on their own, they did not drift to the west. On their own, they would not move to the west. So, how did they move? It was because they were held by the moon and the sun. Now, how were they held by the moon and the sun? Because the moon and the sun would exert a very strong gravitational pull of attraction. And as the planet would continue to rotate from west to east, again, I would say, focus on the part that the planet is rotating from west to east. Lay your attention on that particular portion, that the planet is rotating from west to east. So, if the planet is rotating from west to east, let's suppose here I have a landmass. Now, here I have the moon. Moon is attracting significantly, is attracting the landmass. Moon is not able to attract the entirety of planet Earth, but it is attracting the landmass as per Wagner. So he said, if this is the landmass, now moon is holding it in this place because this is where the moon is. So as the landmass is rotating and the planet is rotating, this landmass is being held in this place. And then eventually, as the planet continues to rotate, what will happen? The land will get broken. Why? Because one portion is consistently held by the moon. So eventually, the landmass would get broken from the earlier one and they would be held in their own place. Why? Because they are being attracted by the moon. Now, the planet, again, I would focus, is consistently rotating from west to east. So, for an individual who is standing here, let's suppose, now, for that individual, this motion of the continent would appear to be in what direction? In the westward direction, isn't it? So that is why you have the westward drift of the continents as per Alfred Wagner. Is that understood? Is that understood? Good. Right. And Wagner theory vis-a-vis India and its geology and geography. What do you mean by that question, Vikram? But even the moon rotates, so it would make changes. Again, I would say, please don't judge it on the present day scenario that you have. Just think about it, what Wagner said, what Wagner was thinking at that point of time. Try to get in his shoes. Okay? Right? Now, uh, after this, can we move ahead? Thank you. So now we move ahead to the second reason. And the second reason that Wagner cited was to prove what? To prove movement away from the poles. This is what he cited as Polflucht in German. This was cited as Polflucht in German, or the exact English translation would be flight away from the poles. From the poles. So basically, he was absolutely convinced that the Gondwana land significantly had various different continental masses, including South America, Africa, India, Australia, Antarctica, all of them situated near the South Pole. And since that point of time, these land masses have come around the region of equator. All these land masses have escaped from the region of the poles. So, for this, in order to prove that, he cited the responsibility of two forces. Okay, so for this, as per Wagner, two forces were responsible. Which were these two forces? One is the centrifugal force, and the other would be force of buoyancy. Okay, now here, what is this centrifugal force? So whenever an object is rotating in a kind of a circular motion, let's suppose, or any kind of a motion around a center, that object experiences a force away from center and towards the center as well. For example, take a ball tied to a string or any kind of material tied to a string and try rotating it with your hands. After some time, you will experience that the object will tend to fall away from you, will tend to move away from you. Similarly, if you try to ride a bicycle in a kind of a circle, you'll find that there is an outward force acting, where you will have a kind of a tendency to fall outwards as well. So that is your centrifugal force. That force is basically force acting away from center in a rotating object. And force of buoyancy, we have already talked about, the force which keeps things afloat, the force which is responsible for the flotation of the object. So, here, when we talk about these two forces, how is it that Wagner basically ascribed the flight away from poles in this case? So, he said that look, the shape of the planet Earth is, it is not a complete sphere, it is an oblate spheroid in a way. So, here, basically, it is slightly bulged at the region of equator, flattened around the region of the poles. So if this planet is consistently rotating from west to east, where do you think that centrifugal force will be acting? At what portion of the planet do you think the centrifugal force is acting if it is flattened around the poles and bulged around the region of equator? Where do you think? Very good. Around the region of equator. As it is rotating like this, equator is also, this portion is also rotating. So the centrifugal force would act outwards here. Centrifugal force. Okay, they would be acting on the outwards because the equator is also rotating with a great speed, around 1600 kilometers per hour is the speed. And with that speed, if it is rotating, objects will experience a force outwards. Now, you also have the force of buoyancy. What is that force of buoyancy? Pushing the land masses upwards as per Wagner. That force of buoyancy was acting. Why? Because the continents are floating freely. So he said that look, all the portions of Gondwana land that we talk about. Now, on this, you had the force of buoyancy as well, pushing it upwards. Along with that, there was centrifugal force. So automatically, these land masses, they tried or they wanted to come to this region around the central portion, right? Around the central portion, where they would experience as per the centrifugal force. So the centrifugal force and the force of buoyancy, they would push the land away from the region of the poles towards the region of the equator. So this centrifugal force acts in the outward direction around equator. So land masses would be pulled towards equator, right? How and why? Aided by force of buoyancy or the buoyant force, they would float away from poles. Okay, this is what he cited as the flight away from the region of the poles. Flight away from the region means movement of land away from the region of the poles in general. So that is the other reason that he cited. Now, what do you think? Does that make sense? Do you think that is something which can lead to the movement of continents and the breaking of the continents and the movement of continents towards the region of the equator? Absolutely no. So the assumptions, the reasons cited by Wagner, they were absolutely ridiculous. They were absolutely incorrect. This is the reason why the continental drift theory, despite the very accurate evidences that it relied upon, this theory was ridiculed, this theory was made fun of. Alfred Wagner was boycotted by the entirety of the geographical community. In fact, when his theory became public, and American geographers, in fact, they went ahead and they had various different seminars where the theme would be to contradict and ridicule Wagner. So much so that in one of them, even F.B. Taylor was called. F.B. Taylor was the first one, if you recall, who told that the continents could move. Now, F.B. Taylor was called upon and he was asked that, look, you also supported this theory. You had also talked about that drift, and that means you would also be supporting Wagner. F.B. Taylor also said that, look, I did not say these theories. I only told about the possibility that the continents could move. But this person is mad. This person, the reason and the assumptions that he has cited is mad. In fact, in the later years, there was not much amount of academic help which was lent to Alfred Wagner at all. And he was one of those climatologists of par excellence. He was one of the geniuses of his generation. He died in a kind of a very different circumstances as he was moving in solitude towards Greenland to carry out his further studies. It was only after his sad demise. Even then, the world did not realize, and even then, the world continued to make fun of him. It was only 3 to 4 decades later when various different other evidences came to the fore, based upon scientific experiments, based upon the study of earthquakes, study of volcanoes, that people realized that what Wagner had basically postulated in 1910s, that is something which is indeed a reality. It is a different matter that the reasons that he cited was still very wrong, is still very incorrect. But the evidences that he indicated, all of them point to one fact, that the continents, the land that we are standing on, that we are sitting on, or in certain cases that we are sleeping on, that land is moving. That land is not stable. And that land has been moving for millions and millions of years. That land has taken various different shapes and sizes. That is why, despite the fact that this theory was rejected, this theory is always considered to be as one of those pioneers who have explained about the present day shape of continents and oceans, and who have laid a significant amount of foundation into understanding and evolution of plate tectonic theory. Okay, so that is where the contribution of Alfred Wagner should always be highlighted in the answer in positive light, whether you are writing it for GS, whether you are writing it for the mains or for the optional. Contribution of Alfred Wagner has to be highlighted in a positive aspect, that what he did, the evidences that he looked into, that were correct. The very imagination that the continents could move, that in itself was path breaking. Okay, so as we come back after the break, now we take a break. So as we come back after the break, we'll take a look at the type of question which has been asked from this area, and then we'll move to the other theories. Okay, so let's take a break. um, can you give basic example of centrifugal force? So take a string, any object tied to a string, rotate it with your hand. That object will have a tendency to move away from you. That is your centrifugal force. Okay. So that is basically about the continental drift theory. Let's take a break of 15 minutes and we'll be back after 15 minutes. We'll be back by around 7 p.m. Okay. A confirmation about the audio, please. If the audio is clear and available, kindly confirm. Thank you. Okay. Dhruv, I would suggest that for understanding the international dateline, we have put up a video on YouTube with a graphical animation and an animated representation. You can also take a look at that. If the recordings of the sessions they still don't end up clarifying your doubt, you can always take a look at those YouTube videos that we have put. These are a new series of videos that we are putting for geography, where we are using the best type of animations. So that is something which will clarify significantly. Now, Ujwal and Sayed, basically, when we talk about the centrifugal force, the centrifugal force is something which acts away from the from the center, right? So, in the case of the planet Earth, which is slightly bulged around the region of equator, as the planet rotates, the centrifugal force will be acting on the outwards, on the outside direction, and that is where the pull will be generated. The centrifugal pull will be generated. So all the land masses which were actually present around the region of the poles, they would break away and they would be attracted towards that centrifugal pull. That is what Wagner postulated. It is not correct, but that is what he said. Okay. And Nagendran, yes, your question is visible. And then another, does the centrifugal force has any impact? Not significant. Slight movement is created, but then not significant. Laksh, not the knowledge series. This is the new series of videos that you will find on Byju's IS YouTube platform, and you will find the animations of various aspects, latitudes, longitudes, about the international dateline, about the shape of the planet, the rotation of the planet. All of that you will find there. Okay. Recording videos in tablet also have those animations. Yes. Okay. Uh, Please don't fear us by teaching physics. See, I am trying to refrain as much as going into the portion of the physics and portion of science as you are. So I am trying my level best not to indulge in the portion of scientific discussion. I'm trying to help you here in order to understand by the day to day examples, the common day examples. So that is something which will help you out. Buoyant force is the force where you have any floating object. That object floats. Why? Have you ever thought about it? Why an object floats? Why is it that you have a plank of thermocol or a plank of wood which tends to float, but a kind of different materials which don't float significantly? So you would have studied about Archimedes' principle in your sixth or seventh class or eighth class of science, right? I'm sure all of us would have covered our school till 8th, ninth, 10th, etc. So that is basically, and in order to experience this, again, I would reiterate, do one thing, take a piece of, let's say, take a piece of thermocol and fill the bucket with water. Try to immerse that thermocol in the bucket of water. After some time, leave that thermocol. You will automatically observe that the thermocol comes up and floats on top. So why is that? Which is that force which pushes the thermocol up? It is the buoyant force. So any object which floats experiences an upward force that is referred to as the force of buoyancy. Okay. Yes, Yuvraj, correct. And Bhagya, regarding the daylight saving time, that is basically in order to save the or in order to have maximum utilization of time. So you have, for example, sunrise happens in Arunachal Pradesh almost an hour before when it happens in Gujarat, right? So when you have the sunlight happening much earlier, so during the summer season in many of the areas the clock is basically adjusted 1 hour before, so that people can work with maximum efficiency during the daytime, during the daylight. However, nowadays it is not followed quite significantly, because nowadays you have efficient lighting and so on. So nowadays the daylight saving time is not used, but when the condition was prevalent where you had to be dependent on the solar light. That is where the clocks would be adjusted in the summer in those areas which would receive sunlight earlier. For that matter, in Assam, in the tea gardens of Assam, even today, you have the chai bagan time, and that chai bagan time or the tea garden time is basically something which operates different from the Indian standard time, where it works totally completely based upon the sunrise and the sunset. And during the summer, when the sunrise happens earlier, the clock is adjusted around half an hour earlier as compared to the rest of the country. Okay. And the assumptions, Muni, that Wagner actually took or he assumed was in order to prove the reasons that he cited. So basically, the assumptions that he made was that the continents which would represent Sial, those continents are freely floating over the region of the mantle or Sima, and that is why they would experience that force of buoyancy. Okay, right? Why buoyancy force doesn't act on heavy object? It acts on heavy objects as well, but you have a principle of flotation, the Archimedes principle. The mass of or the mass of water displaced is equivalent to the force, then the object floats. Okay, is that understood? Vivek, does it have an impact on tidal waves? Which has an impact on tidal waves? Moon's gravitational pull has an impact on tidal waves, if that is your question. Which rocks are the hardest? Generally, the igneous rocks. And Laksh, being in mech engineering, would geography play a vital role? Yes, absolutely, yes. Why not? Now, here we take a look at one of the previous year question and a PYQ. This is for 10 marks. This was asked for 10 marks, and this is a question that UPSC has asked multiple times. It has repeated it multiple times in the mains paper. So this is expected to be written in 150 words. Okay. So the question is, what do you understand by the theory of continental drift? Discuss the prominent evidences in its support. Now, how do you create an answer? So, first of all, here you have to understand that the question has two particular parts. Okay. The first part is, what do you understand by the theory of continental drift? And the second part is, discuss the evidences in its support. So, whenever you are writing the introduction for any answer, it always has to begin from the flow of the question and has to address the first part of the main question. So, has to address the first part of the question. So, here in the introduction, what will you write? So, in the introduction, you can create a kind of an answer where you write that continental or the theory of continental drift provided by Alfred Wagner talked about the existence of a supercontinent named Pangaea, which eventually broke down and the continents drifted to take their present shape. That is it. It will take you maximum around 10 words to write this. And then after that, you can write again in the portion of the introduction itself that Wagner based this theory upon, or Wagner postulated this theory based upon a set of evidences that he came across. Now, that is your introduction for a 10 marker question. For a 15 marker question, your introduction can go up till 25 to 30 words, sometimes even 35 words. But for a 10 marker question, your introduction should be restricted to around 20 to 25 at the max. Okay. Ideally, it should be around 20 to 25 words. So that is where you write that Wagner basically postulated his theory based upon certain set of evidences. Now, what you have done by writing this sentence or inserting this sentence is you have created a flow or an introduction that what your body is going to consist of. So after this, when you create your body, right? when you create the body in this case. So in the body, you have to write that the evidences, they range from geological to paleontological, and they all point out to one existence or one reality, that the continents would have been a single mass and they have broken up. Now, what I would also suggest you to do is that in between the introduction and the body, please insert a diagram for any answer that you are writing for geography. Please understand this. For any answer that you are creating of for geography, diagram is a must. There is no way that you can write an answer of geography without a diagram. You need to have a representative diagram. So in this, what is the representative diagram that you will provide? So here, in introduction, what you have written? You have written about the theory of continental drift, isn't it? So here, you draw a rough diagram of the planet, right? You draw a rough diagram and a series of these diagrams where you talk about that how you had a very simple rough one, that you have Pangaea. That Pangaea got broken into Laurasia or Angara land and Gondwana land, right? And that eventually broke into the various different continents and oceans. So that is sufficient there. Then in the body, when you are writing the body part, there you have to classify the various evidences. So in this, you can group the evidences in bullet points or sub paragraphs. So for example, here you have the geological evidences. Evidence. Akhil, diagram need not be absolutely accurate, but diagram should also not be very absurd, that you have no clue what the diagram is about. So it should be slightly giving an idea about to the evaluator that what you are trying to convey here. So in the case of geological evidence, here, first of all, you talk about the origin, right, of rocks. There, you talk about how the origin of rocks in the region of Appalachian Mountains in North America and the region of Scottish Highlands, they have a similar kind of an origin. That is something you can highlight. Brazilian Highlands, as well as the region of Western Africa, the rocks have a similar origin. Then you talk about placer deposits. You also have to talk about the jigsaw fit of the continents. Now, in the case of, in all these, you have to write this and then write a couple of sentences about it. It should not be like a table of content. You have to, for each one of them, you have to write a couple of sentences elaborating what you are trying to mean by that. Okay, for example, when you are trying to write about jigsaw fit, so here you have to talk about that how the various different edges of the continents, they have a resembling shape, and there you can indicate a rough diagram of South America. And so here also diagram is required. Okay, then after that, here you have to talk about the glacial evidences. Okay, you talk about the striations and tillite deposit. Then you talk about the paleontological evidences. Now here, I want you to listen very carefully for this point. Now, majority of the candidates, and when I say majority, 99.9% of the candidates, when they write an answer, they write about what they know. They don't write what the question is asking. Okay, that is a kind of an approach that we have developed right from our childhood days, since our school, since our college, where the effort would be that you have to fill the pages. So, whatever you know, write it down. That does not work. That approach doesn't work in UPSC. It might seem to be very similar here. It might seem to be a kind of an oxymoronic statement to make, that how is it that we are writing what we know and not what is asked in the question. So here, the question is asking you about the theory of continental drift and the evidences. Now, many of the candidates, what they will start doing is they will start talking about the buoyant force, the centrifugal force, the assumptions made by Wagner, the reason cited by Wagner. They will exceed the time limit, they will exceed the word limit as well. But that is not at all required, because that has not been asked in the question at all. So please always, while you are writing an answer, read the question carefully, understand the requirement of the answer. It might seem to be a very simple statement to make, but that is what creates a lot of difference. Okay, in the marking pattern as well. When you we also, when we evaluate many different copies, when on many different answers, when we come across a kind of a answer by a candidate where they have exceeded the word limit and they have elaborated upon areas which are not even asked, that never creates a good impression. That creates an impression that this candidate is trying to badger through by whatever that person is knowing, not understanding the requirement of the question. So that candidate is always given less marks. Don't do that. Always take a look at a deeper look at what is asked. So here only the evidences are asked. So after you have pointed out the evidences, after that you write that these all these evidences indicated a similar reality, and that is that the continents would have been together at one point of time, and then they would have been separated to their present shape. Now, one final sentence in the body that you can write is, Wagner used various reasons, such as the reason of the tidal force, the force of buoyancy, and the centrifugal force to explain his various or his theory. Right? That is it. By that particular sentence, you are also indicated to the evaluator that you know what this content is about. And also ensure, when you are writing an answer where you are including something important, where you want the evaluator to look at what you have written, underline that word, underline that phrase. But it should not be like many of us, we have a habit of underlining. And I have seen this in many of the cases, that in the name of underlining, what the candidates will do is they will underline like this. Now, if you underline the whole thing, the very idea of underlining the concepts, that goes out of the window. So underline only what is relevant and what you want the evaluator to focus. Because please don't have the kind of an assumption that, and this is again one of the other common fallacies, that anyone, any individual that you pick, and for this, I take 100% of the candidates. When the candidates, they write an answer, they feel that it is the best answer which has ever been created on planet Earth. This is the best answer that anybody could have written. And by reading this answer, the evaluator will be so very happy that the evaluator will not only give me marks, that evaluator will give me extra bonus marks as well. So get rid of that presumption, first of all. The evaluator is not interested in your copy. With that assumption, you have to write an answer. So when you write an answer with that assumption, you ensure that the diagrammatic representation, the underlining, is done strategically to attract the attention of the evaluator in those areas. For example, any government scheme that you are citing, any kind of data pointer that you are highlighting in the answer, underline that. If it is correct, if it is wrong, don't highlight it. Okay, if you're not sure about it, don't highlight it. So highlight that, not by a highlighter, just an underlining with the pen itself will do. Then after that, you come to the portion of conclusion. And Nazarkar, in intro, can we talk about FB Taylor? Why? Again, I come back to the same aspect. Why will you write about FB Taylor? If this would have been a 15 marker to 50 word answer, maybe there was a scope. But if you don't have that scope, why would you write about FB Taylor at all? Okay, or leave it to the intelligence of the evaluator that you know this much. So when you write the conclusion, conclusion is generally a summarization of everything that you have written above. So, based on the above set of evidences, or if you have already written that portion in the body, you can write that the continental drift theory was very instrumental in helping us understand that the continents can indeed move. This formed a bulwark or the basis for the evolution of further theories like plate tectonics, which help us understand about the realities of the movement of planet Earth. Now, in this case, when you are creating this kind of a conclusion, what you are doing is you are highlighting the importance of the continental drift theory, and you are highlighting that how this continental drift theory has been instrumental in the postulation of plate tectonics as well. So that is something which is required. Okay, Vivek, yes. Can we say that this theory challenged the permanency of continents in introduction? Yes, you can obviously write that, Prem. Answer right in point or paragraph, anything. Generally, I would say that make a kind of a bullet point or a sub point, write the topic heading, subtopic, underline it, write couple of sentences after that, or 2 to 3 sentences, then again another subtopic, and that is how you should proceed. Okay. Yes, conclusion should always be in a positive aspect. Somu, does UPSC allow different pen color? Blue and black is what you should use, but there also you don't have that much time to be very creative with the pen color. How many marks one will get after everything like this? So in a 10 marker question, you will be able to score around 5 to 5.5. And if the evaluator is indeed very happy with your answer, you will get around 6, maybe 6.5 if you are lucky. Okay. And For limitations, we could just say the actual forces generated the rotation of the earth were calculated to be insufficient to move. Oh, yes. Somile, you can do that. Yes, Anurag, I will take a look into it. Should we draw diagrams with pen or pencil? Anything, whichever is convenient. Because please understand, from the time of reading the question, understanding the requirement, creating the answer, highlighting, underlining everything, you have got 8 minutes. So, what you do in those 8 minutes is what counts eventually. Okay, right? So, there is no scope of getting an 8 or 9 in a 10 marker. Absolutely not. I hope we understand that we are not in class 6 or class 10th anymore, right? So, getting 100 out of 100 and full marks out of. So, I hope you are able to fathom what is the mark scored by people in GS1. In GS1, GS1 is of 250 marks. You have all the various toppers. If you look at their marks, what is the marks that they score out of 250 in GS1? They score around 110, which is very good. Considered the portion of GS1 and the marking of GS1, it is very good. A very good marks will be 110, 115. Otherwise, the general people who qualify, they you will find their marks to be around 100 plus minus 2 or plus 5 minus 2. So revolving around or moving around between 97 to 105. So out of 250, if you are given 97 to 105 marks, it is not because you are a poor candidate. It is how the scoring is done. Okay. How to write an answer. My dear friend, that is what we have been talking about, haven't we? Is there a need to make diagram in the notes? Depends. Ideally, I would suggest that even in the notes, you should have a diagram. You should have an image for all the questions of geography. Minimum of one diagram is required. And you can inculcate this habit into other subjects as well. So generally, you will find that candidates who succeed with geography optional, they get very good marks in GS papers as well. And why is that? Because that habit of representing flow charts, block diagrams, and various diagrammatic representation, that is something which helps them. Ideally, the candidates think, why should I draw the diagram for this? The evaluator would be knowing this at least. That is why that person is the evaluator. Don't take that assumption at all. A diagram in your page is very refreshing for the eyes of the evaluator. Keep that in mind. Okay. Any impact of handwriting should be legible. That is all. It should not be that what you have written is like a doctor's prescription that even the evaluator is not able to read. In fact, when we have had the opportunity to converse with a few of the evaluators who do check copies for UPSC, all of these, by the ways, are very senior university professors. Many of them, they come up with the kind of a suggestion that the general practice has been, I don't know if it is prevalent even today there is or nowadays there's a greater scrutiny, but the general practice is that a candidate is judged based upon the first two to three answers which are read in detail. After that, rest of the answers, they are simply looked at in a glance, because the evaluator is paid for every copy that they evaluate. So, in the first couple of answers itself, they make up their mind whether you are a candidate of a good caliber or an average or a poor category. So, all the marks which will be following, they will have a kind of a common template. That is why when suddenly they will come across the answers of geography and they find the diagrammatic representation, so regardless of the fact if your earlier answers have been good or not, you have an opportunity to shine. How much marks does a good answer get? Generally around 50 to 60%. Okay. Yashi, anything, any of those. Yes, Gulam, we'll do that. Should I write in simple language or tough? As simple as possible. As simple as possible, unless and until it is a essay paper. Essay paper is where vocabulary and English comes to play. Otherwise, keep it simple. Okay. In main, should we have to write answer in serial? There's space provided. There's space provided for all the answers. 6 out of 15 is a good marks. You have a scope to increase to 7.5, but it is a very good marks for the initial answer that you have written. How to manage time? By practice as many. So again, I would tell it today itself. Maybe I'll repeat it during the course of our journey for 24-25 modules. See, any candidate who has secured a top 20, top 30 rank, that is what you all should be eyeing for. Top 20, top 30 rank, you'll find out that they have written or practiced close to around 1000 to 1500 answers. What happens generally is the candidates, many of the candidates that I have encountered recently, after writing five answers, they get tired that, okay, my marks is not improving, what to do? So don't get disheartened. The real improvement starts happening after you write 40, 50, 60 answers. That is when some improvement starts to indicate. So all that time management practice, that is what is the essence. Okay. And Vishnu, conclusion basically has to be in a way forward or a positive aspect. So when you have in geography questions such as, let's say, the problems faced by urban India, let's suppose. Now for that, in the conclusion, you have to write in a kind of a way forward that if we take or if we resolve these issues, then the future is significantly going to be brighter, providing opportunities for millions of people, etc., etc. So you have a positive aspect. And why do I say a positive aspect? Because understand the nature of the game. Sun Tzu, the very famous Chinese philosopher, had said that you win a battle by knowing the mindset of your enemy. In this case, the enemy is UPSC. So understand the mindset of UPSC. The main answer that you are supposed to write, that individual who is evaluating your copy, that individual does not know the background from which you are coming from. That individual does not know the struggle that you have been through. That individual is not concerned about whether you have put in more time or less time. You will be judged based upon your writing skills, what you are able to exhibit. That is why UPSC, after the second ARC or the Administrative Reform Commission report, UPSC has made it a point to encourage those kind of candidates who have a kind of an ability to find answers to the problems. Not the ones who are pessimistic in nature, not the ones who are good in finding issues, those who are good in finding solutions to the issues. So that is why conclusion always create in a positive aspect. Okay. Paleontological evidence, Kirtana, is basically the evidence or the fossil remains which have been found in various different continents simultaneously, and that is possible only if the various land masses would have been together. Mohammed, as I already said, that basically when you take a look at the answer copy, you have the questions and you have the space allocated. Sakshi, again, I would say practice. Should we go through some of the last 10-year question paper? Yes, you should, Aishwarya. So that is what we will be going through as we continue our journey as well. Okay. How can I make my own notes out of lecture and book? So after you have read a topic, write it down in your own words what you have understood without looking at the book, and then again recheck whether you have missed out a point or not. Is India still floating? No, India was never floating. But is India moving? Still, yes. Yes, Astha, enough space will be provided. Vishnu, you can mail to IS Live. CSAT is getting tough. That is why you need to have practice, as much practice. Guru, along with current affairs, yes. Then Nagentran, where to look for model written answers? So the main test series which are being conducted. So for that, model answers are being provided. You can take a look into that. Urbasi, yes. Urbasi, yes. Conclusion should generally be positive in most of the cases. Shama, will this class be fruitful for both prelims examination and S? So, if depends from the sessions, we have had candidates who have secured double digit rank as well from these online sessions. And from these online sessions, we also have had candidates who have dropped out after first 5, 7 classes themselves. And again, next year they come back that it is not clear, so I'll do it again. So it depends upon how you utilize this. Glacial striations mean the kind of sinuous lines which are created by the crushing weight of the glaciers as they end up moving. Is it sufficient for 10 years? 10 previous year questions, 10 years previous questions is sufficient. Okay, right? Now, 11th and 12th, Gaurav. Vikram, what are the ancient animals called who live in deep water? The benthos. Vikram, your question is not visible. I'll take. What is the word limit margin? 10%. 10% is the word limit margin that you can exceed. Okay. Now we come to another portion of this particular aspect after the continental drift theory. Simultaneously, in the later 1900 or in the later period of 1910s and 1920s, you had the postulation of what is referred to as the convection current theory. Now, this convection current theory basically is provided by Arthur Holmes or Sir Arthur Holmes, who was a physicist. Okay. Now, Arthur Holmes, who was a physicist, provided this convection current theory to indicate that how heat, basically the residual heat, yesterday we talked about that how residual heat is still trapped to this date, it is trapped in the interior of the planet. And we also talked about the fact with a brief sentence itself, but we touched upon the fact that the various events that we experience on the planet's surface are a resultant of that residual heat which is generated in the interior or which is still remnant in the interior. Now, he said that the heat is transmitted by the convection current. Now, what is this convection current? Again, for those of us who are uninitiated about this, let us take a very simple example here. Let us take the example. I'm sure, again, all of you at some point of time in your life would have boiled water. At least you would have done that. If not, it is high time in your life that you experience these worldly things, boiling water in a pan, etc., or a utensil, right? Now, let's suppose you take a jar, you fill it up with water. Okay. Tillite deposit, Tarun, is the deposit carried out by the glaciers. The fine particles that they deposit, that is referred to as tillite. Now here, let's suppose you put a flame. You heat the water. If you have not experienced this till now, after the session, do experience this. Now, when you heat the water, what happens? Does the bubbling effect come immediately on the surface? No. Initially, what happens? You will have small bubbles which will develop at the bottom. I'm sure you would have observed that. Small, tiny bubbles, they will start developing at the bottom of the vessel. Now, these bubbles, after some time, you will observe, because bubbles are what? Gaseous particles, water vapor. So they will start traveling upwards. Let me use a different color. So they will start traveling upwards, right? They will come to the top, and that is when you observe some bubbling on the surface. In the meanwhile, as the bottom portion has slightly elevated and come to the top, what will happen is that the colder waters which are present, they will replace these bubbles at the bottom, isn't it? These colder waters which are present from the top, they will replace those bubbles at the bottom. So they will also get heated, they will also rise to the top. Then another cold ones will replace them. Now, once this is done immense amount of times, that is when you observe a continuous boiling of water on the surface. I'm sure all of you would have observed this. If not, observe it today. So this is what is referred to as a convection current. This is what is known as a convection current. So, in simple terms, when we talk about convection current, it is a manner in which heat is transferred from one region to the other. In this case, from the bottom of the vessel to the top of the vessel, heat is transferred. That is by the movement of the particles. That is what is referred to as convection current. Now, how is this convection current relevant when we talk about the planet Earth? I'm sure already you would be associating with the portion of the residual heat, but let me elaborate upon it. So, let's suppose you have a crustal portion. Let's suppose. Then you have the region of the mantle. And then you have the region of outer core. Now, understand this portion carefully. Okay, observe this area carefully, understand this. It will help you in later concepts. So, this residual heat is trapped in the region of outer core. So, this residual heat, time and time again, is emitted from some portion. It continues in that area, heat is produced, then it extinguishes. Then heat might be produced in some other area, or simultaneously in 2 to 3 different locations, heat might be produced. Right? You won't have a kind of a uniform emission of heat from the region of the core in all directions. Heat is produced in certain sections, it continues for some time. And by the way, in geography, just to get you used to that terminology, in geography, when we say some time, it basically spans for few hundred millions of years, right? For in your history, polity, and other subjects, when you talk about some time, it might be few days, few months, few weeks. In geography, some time is referred to as few millions of years. That is why when we say Himalayas are the youngest fold amongst the youngest fold mountains, and we say that the Cascade ranges in North America have been created very recently, we are talking about 2 million years back. And when we say that in the near future there is going to be a fourth range of Himalayas which will come up, we are talking about 5 to 10 million years ahead. So that is where the time scale varies. So that heat is produced from some location. It continues in that region maybe for, let's say, 200 million years or 50 million years and so on, and it will extinguish in that region. And then maybe from some other place, again residual heat will try to escape. So again from some other region, residual heat will try to escape. So like that, the planet is continuously losing that residual heat. But then that residual heat, how does that impact the surface? How is it that it travels up till the region of the crust? So it goes through the region of the mantle. Now, yesterday, what is it that we looked at and what is it that we understood about the property of the mantle? So when we looked at the mantle, we observed that mantle is a kind of a compressed solid, isn't it? A compressed solid where deformation is easier as compared to breaking. So materials, they can change their shape easily because of the high temperature and high pressure, but the density is also very high. So here, when we talk about, here, let's suppose residual heat is produced from this region, let's suppose. Now this is the source of heat. So what it will do is, it will melt the portion of the mantle immediately above it. Immediately it will melt. Why? Because that heat is provided. Just like in the case here, bubbles are formed at the base. Just like that here, it will start melting the solid mantle. Now it will get converted into liquid, isn't it? Liquid is lighter than solid in comparison. Liquid will have a tendency to rise up. And in the meanwhile, this liquid, molten liquid, will heat up the matter above it as well. That will also get molten, isn't it? Then again, it will heat up the material above it as well. So slowly and steadily, this molten liquid, that starts to rise up. Okay, that molten liquid starts to rise up. It will rise up, then it will diverge. Right? And just like in the case of a vessel, here you will observe that some part of that solid, compressed, deformed mantle, that will end up replacing. I will use the same color pattern so that you don't get confused. So some part of that mantle will end up replacing this. It will also get heated up. It will also get molten. It will also start rising up, isn't it? Now, here, this is what is a convection current. So this is what is a convection current in the mantle. And why is this relevant? This is because indicates the transfer of residual heat from the interior to the outside. Okay. Now, very quickly, let me recap this, then we will proceed ahead with the convection current theory. So basically, what Arthur Holmes suggested was that, look, just like how you have a convection current, which is important in terms of transfer of heat in a liquid, a similar phenomena is also observed in the region of the mantle. Now, in the region of the mantle, when we look at the region of the mantle, so mantle experiences increased amount of heat in certain areas due to that residual heat which is emitted from the region of the outer core. Okay, that is the source of heat which is provided to the mantle. Now, here, if let's say residual heat is provided, let's say residual heat is provided here. It will melt the material of the mantle immediately above it. That liquid will start to rise, and as it rises it will transfer the heat above, and that is how eventually it will come closer to the surface. It will diverge based upon the obstruction of the surface, and in the meanwhile the colder compressed solid of the mantle will end up replacing the gap created by this rising liquid. So that is how an entire convection current is created. Now here, let us understand what happens if, let's say, as a punishment, I make you stand on this particular place. Even though that is something which is not humanly possible. But let's assume that I make you stand in this particular place. Then what will happen? There can only be certain outcomes here. First of all, because if this is a land, heat is being provided, what can happen? That land can get inflated. Because of that heat, that land can get inflated, that land can rise up, right? Why? Because there is substantial amount of heat which is getting pushed upwards. So just like in any kind of a solid thin substance, you would have observed that when you heat it up, it tends to inflate at the region of the heat provision. So similarly here also, at this particular point the land will either get slightly uplifted, or if the crust is weak enough, then in that case, it will break through. And what do you have in that case? If the molten materials break through the surface, you have volcanic eruptions. And then, as this heat diverges, right? Here, the heat diverges. This is the movement of the heat. Now, let's suppose an individual is standing here and an individual is standing here. A, C. Now, what is it that A and C will observe? Now, the heat is basically pushing them apart. So, due to that horizontal movement of heat, what will you have? The land can get drifted. The land can be pulled and stretched apart. So, when we talk about the transfer of heat, you have the vertical column, transfer of heat. You have vertical column as well as horizontal. In the case of horizontal movement of heat, you have crustal surfaces are pulled apart, isn't it? The crustal surfaces, they are basically pulled apart. And in the case of the vertical column, here, what can we have? We can have a volcanic eruption, right? If the crust is weak, if the crust is strong enough, it can be pushed up, it can get uplifted, upliftment of land, right? But then, when we say vertical movement of heat and vertical movement in general, there is another vertical movement that we have been ignoring till now, and it is the vertical movement initiated here in this particular portion. Now, here, without telling you, I want you to apply your general logic. Science and knowledge of science is not required. Your general logic and your understanding of life around you, the experience that you have lived, with that, you tell me, if the heat is sinking in that area, then what will be the impact on the land mass above it? What do you think? Beautiful. Very good. Kumari Pooja, correct. Chandan, correct. Very good. Manas, correct. So here, as the heat is actually going down, in these areas, you will observe submergence of land or subsidence of land. Subsidence of land. Right. So that is what Arthur Holmes basically said. He did not go ahead with the explanation of what will happen in the horizontal column. He did not go ahead with the explanation of what will happen if the crust is weak or strong. He simply talked about the transfer of heat through the mantle by the help of the convection current. And in fact, once you understand that how that convection current operates and why is that convection current initiated in the first place, because of the residual heat which has been trapped in the interior. Now, that residual heat, when it is emitted, it melts the portion of the mantle as it is traveling upwards. In the meanwhile, the colder portion of the compressed mantle, high density mantle, that will replace the portion which has been lifted up. Again, that will get heated. Again, it will rise up, and that convection current continues. So, this is the convection current theory postulated by Arthur Holmes. Okay, right, correct. Crustal surfaces are pulled apart. What do we mean by that? So here, basically think about it. Let's suppose here I have our, let me tell you with the help of a different example. So that is an example generally which I use in the portion of plate tectonics. But let us take that example here itself. So let's suppose you have a utensil full of water. Now do one thing. You can do this at your home as well. Do one thing. Keep two blocks of wood here before heating together. Keep two blocks of wood A and B, right? Very close to each other or together. Now after this starts heating and boiling up, what will you observe is that A and B are drifting away. And why is that? Because the convection current which is generated, that will push them away, right? So similarly here also, as the convection current is generated, it will pull them away from each other. So that is what is experienced. Okay. Yes, Vikram, convection current applies to liquid itself. Subsidence of land means in those portions the land will tend to sink, form a trench, or in general they will have a movement like this and so on. So that is the subsidence of land. How colder mantle replace the liquid? Because mantle, remember I told you, is a highly dense and a highly compressed solid. Remember we gave the analogy of a coconut, that the crust represents the outer shell and the inner flesh of coconut, that is representing the mantle. So how is it that the flesh of the coconut, if you recall, how is it? It is something that can get compressed. It is something that can get deformed. So similarly here also, due to extraordinary amount of pressure, and there will be a gap created as the liquid rises up, so the nearby portion of the solid, that will be pushed here. Then here there will be a gap, nearby will be pushed here. Like that, you will have an entire convection current. Okay. Now, we, but mostly mantle is in semi-solid state. No, mostly mantle is in solid state. It is only in the asthenosphere where mantle is in a semi-solid state. So as the residual heat is provided, the portion of the mantle melts, and that melts the region above it, and that is how the entire heat transfer takes place. Can we relate this theory to the subsidence of Joshi-Math? Absolutely not. Joshi-Math subsidence is because of something completely different. Now, after this, we come to the portion of seafloor spreading, the seafloor spreading theory. Now, what is this theory about? So basically, this theory was postulated after Second World War by Harry Hess. So, just to give you a brief anecdote and a background story about how this theory came into existence, is basically because of the events which happened during the Second World War. Now, all the scientific developments which happened, they came to a standstill by the time, let's say, in the late 30s, they came to a standstill. The Second World War erupted. I'm sure you would have studied more about it than me. So, when the Second World War broke out, the Germans, with them, they had developed a kind of a weapon which had created a lot of destruction and devastation and also panic and fear amongst the Allied forces. And that weapon was the submarines, what the Germans referred to as the U boats. Now, these submarines could stay underwater, they could emerge, launch an attack on the ship or the vessel, and they could again disappear. So, spotting them was almost impossible. So, Germans were creating a lot of havoc with this. Now, till that point of time, the general understanding for the entirety of the planet was that look, when you take a look at the sea from top, the sea appears and the ocean appears to be flat, the water appears to be flatter. So the general understanding or the assumption was that the base of the sea would also be very flat. But what happened was, in order to catch these U boats or submarines underwater, the Allied forces, they developed sonar equipments. Now, what are the sonar equipments? They are like your underwater radars in a sort. They emit some sound signals. Those sound signals, they bounce back on based upon the obstructions, and those signals, reflected signals, are studied, and accordingly you basically get an idea about where a particular obstacle or where a particular enemy submarine is. Just like what dolphins use for navigation, the echolocation that they use. So those sonars were developed. Now, these sonars were deployed significantly by US and the British Navy. And thereby, and also by that point of time, they had cracked the Enigma or the German code, and they would be able to know the location of the submarines pretty easily. So, the Second World War ended. Now, once the Second World War ended, what to do with all these modern equipments? That is when you had the various naval expeditioners, explorers, etc., who started exploring the bottom of the sea with the help of these equipments. One such American naval explorer was named as Harry Hess. Now, Harry Hess, he started observing the water and he started observing the base of the sea. And based upon his observations, he had multiple different observations that he made. Based upon his observations, he provided the seafloor spreading theory. So, first of all, what are the observations that he made? Those observations are quite unique. First observation that he made was that the bottom of the sea is not at all flat. Bottom of the sea has got underwater mountains, it has got ridges, it has got. Now, what do we mean by a ridge? A ridge is an area of a slight elevation, right? That is referred to as a ridge line or a ridge in general, which has got a slight elevation and is continuous. It is not a hill, it is not a mountain, it is a continued portion of an elevated area. So he observed that the seafloor is made up of all these distinct features. The seafloor is constituted by underwater mountains, canyons, trenches, and so on. He also observed significant amount of active volcanism, that is, active volcanic activities happening underneath the ocean at the seafloor. He also came upon the observation that when he studied the Atlantic, nowhere across the entirety of the Atlantic seafloor could he find any rock or any sediment which was older than 200 million years. I will repeat, digest this, understand this. Nowhere could he find across the Atlantic seafloor any rock or any sediment which was older than 200 million years. Now, this was groundbreaking. Why? Because on land, You find evidences of rocks which are even 3 billion years old. You find evidences of rocks which are 3.2 billion years old, 2 billion years old, 1.5 billion years old. So, how is it possible that at the bottom of the sea you don't have any rock which is older than 200 million years? That means that Atlantic Ocean has been created only 200 million years back. So that means, imagine a world without Atlantic Ocean. So that means North America would have been very much attached to Europe, South America would have been very much attached to Africa, and Atlantic Ocean would have been created. Now, how do we know this? And how will we lead to this? So basically, he observed that at the seafloor, wherever there is an active volcanism in the region of the mid-oceanic ridges, in the middle of the ocean, you have these ridge-like features where you have active volcanism. He observed that the rocks closer to the ridges, you have younger rocks. And as one moves away, you come across older rocks. So what does that indicate? That newer crust is getting created at this region of mid-oceanic ridge, isn't it? Mid-oceanic ridge, don't get confused by that statement. Mid-ocean simply represents middle of the ocean, and ridge represents an upraised portion, continuous upraised portion. So mid-oceanic ridges, which are a site of active volcanism, that is where you find the younger rocks, and away from it you find the older rocks. So that means newer crust would be created at the region of these mid-oceanic ridges, and slowly and steadily they would be pushing the older rocks sideways. That is how here you find the older rocks, and here you find a very new rock in existence. This is basically what he postulated, that the sea floor is where new crust is getting created, and that sea floor is spreading with the creation of a newer crust. Okay, so that is something where he said that the sea floor is expanding, and that is what is the sea floor spreading theory in brief. So first of all, let us take a look at the observations made by Harry Hess. So oceans are not features. First observation that he made: oceans are not featureless plains. It contains of mid-oceanic ridges, rises, trenches, abyssal plains. Don't get worried by these terms. I will tell you in detail about each of these terms when we come to the portion of oceanography. So don't panic about it as of now. Just understand that various features were found. Oceanic rock sample in terms of age were nowhere more than 200 million years old. Continental rocks are way older, as in many areas you will find the rocks to be around 3.2 billion years old across the continents. Now, near mid-oceanic ridges, rock samples were younger, and near the trenches, where do you find the trenches? So, trenches are generally found. Let's suppose this is a continental crust. Let's suppose here you have an oceanic crust. So, this is where you generally find the trenches, right? This is covered with water. Okay, this is your continental crust. This is your oceanic crust. And this is your trenches. Okay, now near the trenches, the rocks were oldest, but they were also not older than 200 million years. Which means what? If near the ridges you have newer rocks, means volcanic eruption is happening here, that is pushing the older rocks to the side near the trenches. On the crest of the mid-oceanic ridges, cracks with continuous active volcanic eruptions were found, which indicated that volcanic eruptions are a commonality in these areas. Age of rocks and the types may be similar for any two places equidistant from either side of the mid-oceanic ridge. What is the meaning of that? It means if I have to calculate the age of the rock, let's say this particular rock, and if I have to calculate the age of this rock, which are equidistant from the ridge, both have a similar age, which means both would have been created simultaneously. So, how is it that creation of a newer crust would take place? Let us understand that. So, for that, understand the basic fact. So, for example, let's suppose here I have a crust. At the region of the mid-oceanic ridge, there is active volcanism. There is significant amount of volcanic activities which are happening. Right. How do we measure the age of the rocks? Let me know, anyone who is aware of it. How do we calculate the age of the rocks? Are we aware of that? Carbon dating. Perfect. C14. So with the help of carbon dating, we are able to calculate the age of the rocks. Very good. So I hope you get the answer, Gurjeet. So here you have volcanic eruption, active volcanism. Now this volcanic eruption will create a kind of a crust. Why? Because materials, molten materials will come up, molten materials will rise, they will solidify here, and this will follow a kind of a convection current here also. It will go like this, it will go like this. So that horizontal movement will continuously be pulling the land apart in a way. Now, let's say after 100 years, or let's say after 10,000 years, again, there will be significant amount of heat. So this portion, that is this central portion that you observe on your screen, now because of that heat and stretching, it will again get cracked up. So here, this will break, and this will have a scenario somewhat like this, where you had the earlier created crust that also separates. Now again, newer materials will come up, and those newer materials will solidify here, isn't it? Again, after some time, what will you have? You will have a condition where the older ones are then pushed aside because of that convection current that you see. So you will have a situation where the older ones, they are continuously pushed to the side. Isn't it? Then again after that, fresh eruption will take place. And again after that, let's say newer crust will get created. So like this, what do you observe? The crust which was created here, it has been pushed to the side, and the crust which has been created here, that has again been pushed to the side. So that means newer crust is created at the mid-oceanic ridges. Yes, Sayed, that is correct. Oceanic ridges, and the older crust is pushed to the side. Now, where will the older crust go? If continuously newer crust is getting created and the size of the planet Earth is the same, the surface area is not increasing, where will the older crust go? So, as per this theory of seafloor spreading, he says that the older crust is consumed in the mantle through the region of oceanic trenches. Where are the trenches to be found? He said, it is not what I am saying. What he said is that trenches which are to be found at the boundary of continents and oceanic crust, to be found at the boundary of continent and oceans. Okay, that is how you have the older crust which is consumed. The older crust gets consumed. Right? So, this was his theory. Now, this theory was based upon the observations that he carried out in the region of the Atlantic, that he carried out in the region of the Pacific Ocean as well. Now, this theory also had a certain set of limitations associated. For example, he did not talk about any kind of volcanic events or any kind of creation of a new crust in the case of continents. He did not talk about the movement of continents at all. And if his theory is to be believed entirely, then for every ocean, for every mid-oceanic ridge, there needs to be a couple of trenches on the sides. But that is not to be found everywhere. So this theory also had a certain set of drawbacks, a certain set of limitations associated. Okay, so I'll show you the limitations. It does not explain the small features on the ocean floors, underwater mountains and ridges, etc. It does not explain. It does not talk about the movement of the continents. It does not speak in terms of the lithosphere, that whether only the crust is impacted or the upper portion of the mantle is also impacted. What is impacted? He does not talk about that at all. But then, while carrying out this study, he also used another methodology to study the age of the rocks. One of the methodology to study the age of the rocks, all of you have said, is carbon dating. Another methodology to study the age of the rocks is what is referred to as paleomagnetism. We have studied about the paleontological evidence just now. This is paleomagnetism. So here, how the older crust is consumed. Okay, how the older crust is consumed, because you have a kind of a convection current here. So while there will be a volcanic eruption in this portion, this convection current will continue to subsume the older crust from the region of the trenches. Okay, he was able to reach the crust of the ocean. The bottom of the ocean can be studied with the help of various different sonar equipments, etc. Okay, limitation, I'll get to that. How is older crust going down near the continent ocean if there is a difference in oceanic and continental crust? Because of the convection current, it is pulled down. Okay, now here he also looked into paleomagnetism. Now, what do we understand by paleomagnetism? So when we talk about paleomagnetism, paleo means something which is very old, study of something which is old. So paleomagnetism refers to study of age of rocks based upon the magnetic property of the rock. So, how is it that you can study and you can calculate the age of the rocks based upon the magnetic property? So, understand this. Whenever you have creation of a new rock, how is it that a creation of a new rock happens? What is the primary rock that gets created? What do you think? Igneous. So, how is it that the creation of igneous will happen? By volcanic, okay. Cooling down of lava or magma, right? Can we say that cooling down or solidification of molten materials will lead to the creation of a newer rock? Good. Hold that thought. Now, when we talk about the planet Earth, yesterday we had talked about geomagnetism. We had talked about that how planet Earth has got its magnetic properties associated with it. And we also talked about the fact that how these magnetic properties keep on changing continuously. Now, we, with the help of the studies that have been carried out for the past 100 years, we have developed enough computer simulations that we are able to calculate what the magnetic field would have been, let's say, 3 billion years ago, or 500 million years ago, or 200 billion years ago. I will repeat, we have the capability based upon our continuous studies and experiments to be able to simulate and calculate what the magnetic field of the planet would have been around 200 million years, 300 million years, and so on. Right? Now, the geomagnetism that we have studied, that indicates that we have magnetic field lines across the planet. Now, when a new rock is getting created, let's suppose here a new rock is getting created. Let's suppose in this region. Now, as this newer rock is getting created, the molten materials will solidify. But when you have the materials in a molten state, the molecules, the atoms, everything is basically in a molten state. Now, will they experience the magnetic field of Earth at that point of time? Yes, they will. Will they try to arrange themselves based upon the magnetic field of the Earth at that point of time? Yes, they will. So, let's say, as the materials are solidifying, their particles, they will arrange themselves as per the magnetic field which is prevalent. So, when you study an old rock and you gauge the arrangement, the magnetic arrangement of the particles, and you run it and match it with the simulation, won't you be able to calculate whether the rock is 200 million years old or 300 million years old? Isn't it? I will repeat this. So listen to it carefully again. So basically, the magnetic field lines of the planet have been changing continuously ever since its formation. Now we have the capability to be able to simulate and calculate what the magnetic field lines would have been 150 million years back, 300 million years back, 400 million years back, and so on. Now, when we talk about the formation of a rock, it happens by solidification of molten materials. The solidification of these molten materials when they happen. So, how does that take place? So, the particles, molecules, etc., all of them are in molten state. They all cool down and solidify. But in that brief moment before they solidify, when they are still in liquid state, the iron particles, the magnesium particles, whichever are present, they will arrange themselves as per the magnetic field lines of Earth. Now, if we dig back an old rock and we simply observe the magnetic lines indicated or the magnetic properties and the arrangement indicated by the particles of that rock, won't we be able to calculate and match it based upon our simulation that how old is that rock? Whether that rock is 50 million years old or 60 or 100 million years old, we'll be able to calculate that. That is precisely paleomagnetism. So, this is something which he carried out, and this is something which he observed on the ocean floor. And that is how he basically came to the conclusion that the rocks away from the mid oceanic ridges, they are older. So, basically, he observed that, let's suppose, let's consider the mid oceanic ridge here. Okay. Let's assume. Now, here, what he observed was that as you would move away from the mid oceanic ridge, you would observe rocks indicating different kind of magnetic properties. It did not make much sense. That why is it that the rocks would indicate different types of magnetic properties as you moved away? But then later on, after Harry Hess, a couple of scientists, what they did was they matched it with the other section of the mid-oceanic ridge. And to their surprise, they found out that the magnetic fields, let me use a different color, the magnetic fields indicated by the rocks, they are similar on both sides of the mid-oceanic ridge. They are similar on both sides. So that means as you move away from the mid-oceanic ridge in any direction, you would come across the rocks indicating similar age. This is your mid-oceanic ridge. Okay. Similar arrangement of particles. So that indicated as you moved away from the mid-oceanic ridge and you are equidistant away, the age of the rocks is going to be similar. Same age. So that means what? It means they would have been created simultaneously at the region of the mid-oceanic ridge, and slowly and steadily the newer crust which is continuously being formed has pushed them aside. So that again reinforces his theory that newer crust is always getting created at the region of the mid-oceanic ridge, and slowly and steadily they are basically getting pushed aside. Is that understood? Mid-oceanic ridge. Ridge is an upraised portion. Any kind of an upraised portion of land that you come across, that is referred to as the ridge line, etc. That is when it exists in the middle of the ocean. This is your example of mid-oceanic ridge. So when you talk about this world map, many of the times you would have basically observed that the world map represented the blue color representing the oceans. Now, here you would have observed light blue color in these areas. These are your mid oceanic ridges. All these are your mid-oceanic ridges. Okay, so these are your mid-oceanic ridges. Can you provide us in writing about paleomagnetism? No, because I have already done that, and you will find the more amount of written text in the additional reading materials. Okay. Last point of limitation is that this theory does not talk about whether there is only a creation of a newer crust or whether there is a creation of a new lithosphere. Lithosphere, when we talk about, understand, it talks about the upper solid mantle as well as the crust. So his theory was silent about that. Okay. And why are mid-oceanic ridges in the middle? They are not necessarily always in the middle, but as the expansion of the seafloor happens, as the seafloor tends to expand, automatically on both sides it will expand. So eventually, after millions of years, you will find them. For example, observe the mid-oceanic ridge here. Are they in the middle in the Pacific? They are not. This is referred to as the East Pacific Rise or the Chilean Rise or the Chilean Ridge. They are not in the middle of the ocean. Okay. Trenches are basically, when we talk about trenches, these are very deep depressions in the ocean floor. They can go to a depth of close to around 10,000 meters as well, 10 to 11 kilometers from the sea surface as well. Okay. Guru, do you mean that Earth's magnetic field changes from time to time? Absolutely, yes. So how we know the age of rocks? By carbon dating or by paleomagnetism? By carbon dating mostly. By paleomagnetism also you can get an idea about it. Okay. How create rocks? By volcanic eruptions, my dear friend. Volcanic eruptions, when they happen in the region of the mid-oceanic ridges, the volcanic material will come out, they will solidify, and new rocks will be created. Okay. How rocks possess characteristic of the magnetic field. So when you have the rocks which start to solidify, the molten materials, they begin to solidify, the molecules, they will arrange themselves as they are in the molten state. They arrange themselves because these materials will also consist of iron particles, right? The volcanic material, the magma, will consist of some amount of iron particles. They will arrange themselves as per the magnetic field of planet Earth. Okay. Can you please explain in brief paleomagnetism or planteomagnetism? I hope you want to understand paleomagnetism and not planteomagnetism. Paleomagnetism is basically when you have the condition that, or the ability to calculate the age of the rocks based upon the ancient magnetic properties exhibited by the rocks, based upon the magnetic field lines of arrangement of the particles in the rock. That is paleo. Paleo means what? Study of something which is very old. Magnetism. So, by studying of the rocks and their magnetic field, when you are able to calculate the age of the rocks, that is paleomagnetism. Okay, right? I hope that is understood. So basically, this is your seafloor spreading theory. So seafloor spreading theory was observed by Harry Hess and corroborated that the fact that eventually the continents, they do move away from each other in the case of Atlantic, and eventually form the basis of the plate tectonics theory. So it was the first comprehensive theory to talk about the movement and the formation of seafloor. Simultaneously, other scholars such as Mackenzie and Parker and Morgan in the 1960s developed a more comprehensive understanding of the movement of different parts of the Earth's crust, both oceanic and continental. Harry Hess did not tell anything about continental and the related formation. It is explained under the theory of plate tectonics. So that is your seafloor spreading theory. Okay. So yeah, that is what we talked about, that how can seafloor expand when there is no expansion of the planet? That means the older crust would be consumed somewhere. Where is it consumed? In the region of the oceanic trenches. Okay, right? So before we end the session, I want all of you guys to note certain map pointings. I want you to open up the atlas and just locate those areas. So do this map pointing. Okay. First of all, I want you to look into the region of mountains. Appalachians, Rockies, coastal Cascade Ranges, Brooks Range, Sierra Madre, Oriental, and Occidental. If you don't have an atlas, just look at it at Google Map as well. That would also suffice. I just want you to be aware of that. Okay. And then Andes, Alps, Atlas, Great Dividing Range, then Caucasus, Pyrenees, Scandinavian, Ural. Okay. Look at these particular mountains and also then simultaneously look at Red Sea, then Lake Victoria, then Lake Tanganyika, right? Then, as of now, just look at these areas. Tomorrow, I'll give you more areas for map pointing. And when I tell you to take a look at these portions in map, I don't want you to be behaving like a class 6 student. I expect some amount of maturity. When I say behaving like a class 6 student, so how a class 6 student would approach it is they would type this on the system, they would find it, and they would be happy thereafter. I want you to take a look at the location. Which part of North America is Appalachian located? What are the regions around it? Is there an Ozark Plateau near it? Where is it that the coastal Cascade Ranges in North America are situated? Is it closer to the western boundary? Where is it the Rockies are situated? Look at the regions around it. So look at the vicinity areas. That is why I'm giving you map pointing. That the area that you are looking at, look at the vicinity of that as well. Okay. So that is where we'll restrict the session here today. And I hope that the session was helpful to you. We will take up a few questions now and we will end the session. Which atlas should I buy? Any atlas. Any atlas in the market is sufficient for general studies. Roshan, why are you not reply my question? Because your question is very difficult, my dear friend. What is your question? Please ask your question. I'm unable to look at your question. Vikram, are you able to see my question? Oceanic floor is weaker than the continental floor? No, it is stronger. in many of the cases. Webber, you said there were no ridges in every no trenches, no trenches in every continent ocean border. Okay. Vasundhara, accidental or occidental? It is occidental. Occidental means something to the west, oriental means something belonging to the east. It is situated around Mexico, Sierra Madre, Occidental and Oriental. Okay, so when you are taking a look at it, look at Yucatan Peninsula as well. That is a region very rich in minerals. Do we have to remember their location? You have to be aware of them. And Somalia, as the seafloor widen out and get separated from the, uh, get separated from mid-oceanic ridge, does it have to do something with Earth's magneticity? No. See, as the new volcanic materials they start cooling down, they will arrange themselves as per the magnetic field lines prevalent at that point of time. Uh, Aromal, what is the time to start answer writing? Beginning or after developing the content? After developing the content. Before that, get into the habit of writing something. So write any particular concept on your own. Okay. So that is where writing should always be developed. What does the convection current theory convey to us about the transfer of heat? As China is digging a hole of 10,000 kilometer, would it become a problem for Earth? No, absolutely not. 10,000 kilometer? Absolutely not. 10,000 meter it is. Right, it is a 10,000 meter. Please read it carefully again. And Vivek, how mid-oceanic ridges work? Mid-oceanic ridges basically are a site of active volcanism, where you will observe that convection current is in existence and molten materials they emerge out of it. Fresh volcanism happens, older crust is pushed aside, and that is what you observe in these MORs. Tomorrow we will be looking at the plate tectonic theory. So there again we will be taking a use of these mid-oceanic ridges. Okay. If you are not able to write any question, then you can write the next question. Roshan, yes. I hope you are talking about the mains exam. Yes, absolutely yes. Many of the candidates do that. Uh, Under the ocean, is volcanic eruption still going on? Yes, absolutely yes, Anubhav. If yes, then does it affect the temperature of the ocean? Not significantly, because it is restricted only to the bottom portion. Sindhu, no, map pointing has not been given yesterday. What is the topic for next lecture? We have talked about it, Lakshmi. And which advanced book is needed for geography? None of the advanced books are needed. NCRTs for GS is more than sufficient. For optional, you need to cover other areas, but for GS, no. And McDonald, oh, it is not McDonald, Mr. Donald. Okay. Which book should we refer? You should refer to NCRTs, more than sufficient. Byju's Atlas is sufficient, more than sufficient, my dear friend. Is mapping asked directly in mains or is it for prelims answering? Prelims answering. Mains for general studies, no map questions is asked. Yes, Ananya, that is correct. Rajan, how to map point means only see the places that you had given or the countries, continents, etc. Surrounding regions, Rajan. Okay. And as per this seafloor spreading theory, the older rocks formed by the volcanic eruption will be the source of the formation of the continents. No, Shanmugapriya, that is not correct. How many mid-oceanic ridge? Chavan, just to give you an idea, the continuity of mid-oceanic ridge is almost around 56,000 to 60,000 kilometers. Okay. What type of rocks in the sea floor? Basaltic rocks. You have basaltic rocks which are generally rich in iron and magnesium. Okay. And no, Basu, convection current theory does not talk about the movement of heat. Lakshya, so that we get the required information only in maps, as map is vast, so geography through maps lectures have that. Yes, they have that slightly. But for maps, for your examination, I would always suggest to you look at the portion of the current affairs. Thanks, Tarun. And in mains, Afreen, you don't get any question from map. Yashi, tab lecture is different from live class lecture. Which portion of tab lecture do you have the tab lecture of a different faculty, or you have the tablet lectures of mine? So if you have my tablet lectures, it should be similar. The topics covered would be slightly different in certain areas. So after the live class, you can revise it through the recordings as well of the live class that is now available. You can revise it with the tablet as well. Generally, anything which you are comfortable with. 11th and 12th NCRT. Okay. Is that China digging is going to affect the earth? No. Okay. And Sakshi, if we only stick to classes and PPT, it's enough for, along with the additional reading materials and current affairs? Yes. Okay. If solid rocks subsumed in mantle, so how old rocks are formed? So the oceanic older rocks are subsumed in the mantle, not in the case of continent. We study continent, the plate tectonic theory tomorrow. We will be aware of that. Vikram, I have already told you the rocks in the seafloor are generally basaltic, rich in iron and magnesium. Okay. Yes, Ashwarya, that will be sufficient. Mayank, my dear friend, I'm not able to look at your question. How has the seafloor spreading theory failed? It has not exactly failed, but then seafloor spreading theory did not explain many of the facts about the movement of the continents. Why residual heat will escape from outer core, Puja? Because the outer surface, the surface of the planet is colder, the core is hotter. That is why that escape happens. Okay, right. So that is where before Ural it is Scandinavian. So that is where we'll end the session here. And what is Jan and June isotherms in Atlas? It is the temperature reading. Okay, it is the temperature indication and distribution of temperature. Any Yashi, is it needed to revise from lecture also? PPT is also, if you are able to understand, more than sufficient. Why the Earth's magnetic field is changing continuously? Because the outer core in itself, it is not a continuous fluid movement. You have chunks of molten iron present somewhere, getting distributed somewhere else, so the magnetic field lines change. Mayank, in different areas of the planet. Guru, that answers your question as well. Okay, so that is where we'll end the session here for today. We meet again tomorrow where we carry on the discussion about the plate tectonics, the formation of the Himalayas, and eventually we proceed into the portion of earthquakes and volcanoes. That will be all from my side. Hope the session has been meaningful and helpful for you. Till we meet again tomorrow, take care of yourself, relax a bit. Goodbye and have a good night. Thank you.